Well, good evening, everybody.
Good evening, everyone.
Hi, everybody.
All right, can you guys hear me okay?
Yep.
Hey, you're a little faint, but yeah.
All right, I'll move. That's probably better.
Okay.
Is that better, Gerald?
Yep.
All right, great. All right, we passed the sound check. Well, good evening, everyone, and thank you for joining us. Tonight was our scheduled Messier Marathon night. It is still our Messier Marathon night, but it's now a virtual Messier Marathon night. We are at 92 or 93% humidity, John.
92, I think. Yep, 92.
93%.
All I know is it's cold, it's windy, and it's completely overcast.
Right.
Yeah. So perfect night for a Messier Marathon.
Yeah.
Right? So look, that's not going to stop us. We have a lot of information about Messier objects. We're going to be able to show you lots of cool slides and show you where they are. And we're pretty much going to walk through the Messier Marathon so people could learn about this really amazing and interesting catalog. And give you some idea of what it is that Charles Messier was looking at back in the 1700s and what we still enjoy looking at today through our amateur and even professional telescopes.
We've got a complaint that you're still.
We get started though.
We got a complaint that you're still a little soft on your volume there, Richard.
Let me see. Let me make sure everything is right.
Yeah, check. You might want to check.
That was the problem.
There you go. Better. Much better. Yeah.
All right. The same thing happened to me last time.
Okay. Now you're saturating.
Yeah. All right. I'll move it away.
There you go.
That should be right.
Yeah. There you go.
All right. Thanks, guys. So anyway, before we get started, I do want to thank everybody in the community for your ongoing support of the Chabot Space and Science Center. We depend on community support to keep our operations going. We present virtual events all week long, every week, and we have to keep the facility running in order to do that. And we also need to get your support so we can open up later in the summer and be open to the public again, which we're all looking forward to. And I also want to thank our corporate sponsor, Fremont Bank, for their ongoing support of this program and others. So I guess we'll get started. I've got all kinds of star maps that show you where these Messier objects are, and Gerald has all kinds of cool photographs, and all three of us have knowledge about the history and nature of these Messier objects. So, there's the big chart.
There they are.
The periodic table of Messier objects.
Yeah, all 110 of them.
That's right, all 110 of them. And they're all different, and they all fall into various categories of nebula, galaxies, open clusters, globular clusters, even some stars. So we will take you through the tour. So where are we starting, Gerald?
I think we're starting with M77, which is a spiral galaxy about 60 million light years away. Let's see here. I think, yep, I'm going to share my image of M77 here. Right there. There it is. This is a Hubble Space Telescope image of M77. As you can see, it's a spiral galaxy. Like I say, it's about 60 million light years away. It was discovered in 1780, not by Messier, but by a guy named Messier. Hubble, this is one of many objects that Messier cataloged. And before we go too much farther, Richard, we probably ought to just talk about who Charles Messier was and what is this all about here. So let me just take a minute to talk about Charles Messier. Charles Messier was a French amateur astronomer. He lived in he was doing his astronomy in the second half of the 18th century. So for those of you who can't count centuries, that was in the 1700s. And Charles Messier got an idea of a way to make a little extra cash. And his idea was that he would search the skies looking for new comets. And if he found them, he would then get noble people, rich people, basically, to pay him to name the comet after his benefactor. So that was his idea. To find comets, he had to scan the sky with his telescope. Now, his telescope, this is in the 1760s and so on, so his telescope wasn't as good as what we have today. He would scan the skies looking for faint, fuzzy objects in the viewfinder of his telescope. And if he spotted one, he would then watch it for a period of time to see if it moved relative to the background stars. Now, a comet often first appears as a little faint fuzzy blob or object, and if you watch it over time, it will move relative to the background stars. So that's what Messier would do. Now, once in a while, he would find a faint fuzzy object and he would watch it for a while and it didn't move. And when he did his homework, sometimes he found it was actually an object that had been discovered by somebody else. It was not a comet. A lot of times it turned out he had discovered something new, but he wasn't into discovering faint fuzzy objects. He was looking for comets. So to keep from getting confused by finding or discovering the same object over and over again, he decided to make a list of all of the faint fuzzy objects that he found in the sky that did not move, so he wouldn't confuse them with comets. Well, fast forward to today, there are no comets that we know of that are named after Messier, nor none that we know of that were named by Charles Messier, but we still use his list. And that list today is now called the Messier Catalog. There are 110 objects on the Messier Catalog. And it turns out that at a certain time of the year, basically around mid-March, the way they're arranged across the sky, they're all northern hemisphere viewable objects, and the way they're arranged across the sky, you can see all 110 objects if you start viewing as soon as it gets dark, right after sunset, and continue on through the whole night. You should be able to see all 110 Messier objects. So this has become sort of a goal, especially for amateur astronomers, to each year, mid-March, try to see all 110 Messier objects, and we call that a Messier Marathon. So that was our objective tonight, was to do a Messier Marathon, and we were going to start with this object here and work our way across the sky. Unfortunately, Mother Nature had other ideas, but we are part of an international effort to do this. There's a company called Unistellar, which makes a very unusual type of telescope called an EV scope. Several of the staff on Unistellar are also members of the SETI Institute down in Mountain View. And they decided to sponsor this event, and they made it an international event. So they have recruited observatories and astronomers from all over the globe who are all doing Messier marathons over a very short, about a 1 week period. They pick a night that they want to do it, and then they do it, and then they report back to the Unistellar guys about what they found, and maybe send some pictures.
Our report is going to be very easy.
Very, very short.
Yeah.
Nothing cited, saying same.
Yeah.
Found one nebula, the cloud over our head.
The cloud over our head nebula. That's right.
Yeah. What we're calling the Oakland Nebula.
What did you say? That was M111, the Oakland Nebula. That's right. Yeah. Before you continue talking about M77, let me show folks where in the sky that is. So hold on for a second.
Okay, let me stop my share.
You don't have to. I'm able to bump you off.
Oh,
got it.
I got it set up
with the fancy settings here. Okay, so you should be able to see the star map screen here. You guys see that?
Yep.
Yes.
Okay, great.
Yeah.
All right, so the constellation to look for is the constellation Cetus. And Cetus is setting in the west, so it's not an easy to find constellation this time of year anymore. And it's a real challenge to get M77 this early in the evening and this low in the sky. But it's right over here next to this fairly bright star, which is believe the third brightest star in it's the fourth brightest star in Cetus. And so it's easy to find with an amateur instrument or even a pair of binoculars. And the Cetus is easily found by finding Taurus, because the arrow of Taurus points right down into Cetus. So anyway, you have to find the constellation, and once you do, you should be able to find M77, which is right there.
All right.
Mhm.
And I see that there's an arm sticking up there with a laser
Yes,
pointer.
that
Yeah.
is my arm. Yeah.
Okay. And your laser pointer?
Yeah.
Have you
there it
been
is.
properly trained to use the laser pointer?
I have several of them, and I train with using my cats.
There.
Yeah.
Okay, so M77 was our first objective. The next object is M74, which is in the constellation Pisces.
Can I say one more thing about M77?
Sure.
M77 is also a Seyfert galaxy. And a
Oh.
Seyfert galaxy is a galaxy that emits a very powerful X-ray beam. It's an X-ray source, and it's not greatly understood on what causes that those X-rays, but it's usually either a black hole or it could be a quasar. And it's probably a quasar in this case, because it's a very, very bright core, and it has a lot of quasar-like qualities to it, a lot of electromagnetic radiation
That just
causing those
means,
X-rays.
yeah, that just means the black hole is eating.
It's eating, yes.
Yes.
So
It's feeding.
so anyway, there's a limited number of galaxies that are known to be Seyfert galaxies, and this is a notable one.
All right. So let's see. Our next object, like I say, is M74. John, I think you've got some information
It's
about
also a galaxy. It's about 35 million light years away. It was also discovered by Pierre Méchain. What else? Let's see. It's a
obviously
very
a spiral.
prominent spiral galaxy. Yeah.
Yeah, 35 million light years away. Yeah.
It's one of the nicest examples of a so-called grand design spiral galaxy. Because we
What's
see
that
it,
meant?
just that we see it
grand
directly
design
face,
mean? Yeah.
just that we see it directly face on, so we can see the spiral legs, so to speak.
And
very
you
clearly.
notice these dark bands here. This is actually huge clouds of gas and dust, and new stars are forming within those clouds of gas and dust. So we see those bands, dust bands, gas and dust bands like this in a lot of galaxies, and they're always where we see new stars forming. If we take an infrared image of the galaxy, it's in these dark lanes that we see all of the hot spots where these new stars are being formed.
So M74 is, if you thought it was hard to find M77, M74 is in Pisces, which is even lower on the horizon. In fact, let me see if I can get to the share button here. Here we go. And it's all the way down here. Is the laser pointer is pointing right to this location. There it is. And Pisces is barely visible. We would be having an impossible time with Nellie because it's way too low to the horizon. So we wouldn't have even been able to see this one.
It's also another magnitude dimmer
Yes.
than M77.
Right. It's magnitude 9. So not easy to see.
All right. Well, our next object is M33.
Ah, one of my favorites.
Yeah, this is actually part of a group of galaxies that includes the Andromeda Galaxy and so on. Let's see if I can share my Hubble image of this object. There it is right there. It's about 3 million light years away. The Andromeda Galaxy is about 2.5 million light years away. This one is a little bit farther away. When you see pictures of the Andromeda Galaxy, which we will see a little later, you'll notice that there are a couple of, they look like satellite galaxies, and M33 is actually one of those satellite galaxies. And it's another spiral galaxy. It is very common for galaxies to be in groups and clusters of galaxies. So we see that with M31, the big Andromeda galaxy. We see a couple other galaxies close to it, and technically, our Milky Way galaxy is part of that same cluster. All right.
Now, M33 is also very well known for its hydrogen alpha regions, which are star-forming regions, and they're immense star-forming regions. And you can see them in this photo as being kind of the brightish white, yeah, like right around there are the H alpha regions, and they really stand out in the astrophotos that people take.
And what is H alpha, Richard?
It is a particular form of ionized hydrogen that is visible using what's called an H alpha filter. So the hydrogen is excited at a particular level that makes it visible in a particular wavelength of light.
It's kind of down somewhere in the red part of the visible spectrum,
Yeah,
right?
very,
Yes.
very deep red. Yeah.
Right, right. All right. Okay. Let's see. What's our next object?
31.
31. Oh, well, there it is.
Yep.
So let me see if I can share my M31 image here.
Yeah.
Get rid of that. And there's M31, right? There. All right. So here's M31. It's the Andromeda Galaxy, 2.5 million light years away. It's a little bit bigger than our galaxy. And it is, very similar structurally to our galaxy, although it is a little bit bigger. And again, you can see all the dust lanes in here, and
That is
those
beautiful. Mm-hmm.
clouds of gas and dust. That's where all the new star formation is going on. One interesting thing about Andromeda is it's headed our way. The Andromeda Galaxy and the Milky Way Galaxy are gravitationally bound to each other, and we are slowly being pulled together. And right now, we're approaching each other at about 300 kilometers per second. And if you do the math, that means that we're going to start merging in about 2.5 billion years.
Can't wait for it.
So you come back 1 billion years from now, Andromeda is going to be a lot closer. It'll be very prominent in the night sky. It'll be a naked eye object, and it will get bigger and bigger over the next 1 billion years or so. So something for us all to look forward to.
And it's setting right now over the probably over the Salesforce building. And yeah, so it's impossible to see. I'm not going to even bother showing the star map of where it is, because you can barely tell where it is even on the star map. So Andromeda is really one of the, it's pretty much the only Messier object that you could regularly and easily see naked eye in a dark site. Right, if you're way out in Yosemite or out in the desert, you could see Andromeda naked eye.
Pretty much the most distant object that we can see naked eye.
Yep.
And it is one of the local group as well, the closest of them.
And, you know, if Charles Messier had lived in Andromeda, he would have been able to pick out all the globular clusters in Andromeda, which is something we're able to do now. We're able to observe the globular clusters in Andromeda with amateur telescopes.
Okay. Well, the next object is M32, and unfortunately, I don't have an image of M32, so we're going to have to wing it here a little
All
bit.
right, well, let me see what I got here. Yeah, let me see what I've got, and I'm going to share my screen. And here we go. M32. Let's see where we are. M32 is right next to M31. No accident in the numbering there. And let's see if I can.
You have an image, Richard? I have an image from the SED site. That's not a great one, but
yeah, let me see what they've got. Here we go. Sorry. M32. If I can get this to work, which I can't. All right, let's see if I can get it here. 32 photo. Yeah, great. That's about what it looks like.
Yeah, it's not too much to it.
It's a tiny, it's what's called a dwarf elliptical galaxy. And that's pretty much what it is. Dwarf elliptical galaxy, meaning a small elliptically shaped galaxy. Elliptical galaxies are the next stage in galactic evolution after spiral galaxies. It's after star forming has pretty much ceased and the spiral arms have kind of merged into one another, creating an oval blob rather than the distinct spiral shapes that you saw in the previous Messier objects.
All right. Yep. So our next object is M110, the last item on the Messier's list. And I do have an image of that. Stand by here.
These objects that we've been looking at are all fairly close together in the sky because we're looking at them in the order that you would look for them in our marathon. So they're all the ones that are about to set in the sky.
And this one is also in the Andromeda constellation. And let's see, what kind of information do we have on it, John?
Let's see, it's 2,900 kilolight years.
Okay.
So just a little bit farther away than
2,900,000
Andromeda.
Yeah,
2.9 million.
Yeah.
It's not to be confused with the M110 howitzer, which is a completely different thing. So be very careful.
That's right. If you search for M110,
yeah, it's really important that you qualify it with Messier or astronomy.
Right.
All right. You know,
this one was actually discovered by Messier, by the way.
Yeah. But he never included the galaxy in his list, apparently.
Oh,
but it was depicted by him together with M32 on a drawing. So later on, it was designated as M110, even though he never identified it as a separate object.
Yeah, I think his original list had only 107, or maybe it was 104. I can't remember. Yeah. So.
No surprise. It was Carolyn Herschel who independently discovered it, and William Herschel described her discovery in 1785.
All right. Yep. Well, our next object is M52, which is we've been doing a lot of galaxies here. Now we're going to switch to a different object and show you M52, maybe. If I can get it up here. What did I just do?
Oh, this will be an open star cluster.
Now, is that in Cassiopeia or is that in an adjacent constellation?
Cassiopeia.
Yeah.
I see. Are you sharing? Is that you that's sharing? Somebody's sharing here.
Oh, am I sharing? I'm not.
Yeah, okay. You're
I'm not.
confused.
No, nobody's sharing.
No one,
Okay.
nobody's sharing. We don't share here.
Yeah. What kind of people you think we are here?
Yeah.
And I don't have an image. That's the problem. I don't have an image of
All
M.
right. Well, let me see.
So
Let me see if
it's
I've
an
got one on
open
mine. Hold
cluster.
on.
I've got one that's
All
kind
right.
of
So
small, but I can share it. Let's see
Okay.
here.
M52 is the big W in the sky. It's right next to the big W.
Cassiopeia is the W. Yeah.
Cassiopeia. Yeah. And not to be confused with the big W in the mad world, which is another big W, if you know what I'm talking about. So M52.
It's
There we
about
go.
5,000 light years away, and
And
it's
that's
an open.
about what it looks like. It's an open cluster. And
So
John's
let's
got a
talk.
much better image, I'm sure.
I don't know.
No?
But I'm sharing it.
I'm not seeing it.
Oh, you're not.
No.
Oops, my whole screen went blank there.
So
There it is. We got it
Okay.
now.
Okay.
Yeah, that is a better image. I like
Yep.
that better. Yeah.
So an open star cluster is a group of stars that formed. Remember how we were talking about those dust lanes and gas clouds where new stars are forming? When those stars actually form, they form all at about the same time, and they're all fairly close to each other because they're all in the same cloud of gas and dust. And eventually the stars turn on, they start fusing hydrogen, and then they start pushing the cloud away, and eventually the cloud dissipates. And we just went blank here. What happened here?
I'm not sure. My screen keeps blinking on and off here. And I get a message that I can't read fast enough. It disappears too quickly.
All right.
Okay, well,
let me unshare your screen.
All
and
right,
then
go
you can
ahead.
Try it again. All right. Actually, it's visible right now.
yeah.
Good. Okay.
So anyway, the stars once they turn on, they start blowing the gas away, and eventually the gas cloud dissipates, and it leaves behind hundreds of stars that formed from this huge cloud of gas and dust. And those stars kind of linger together for a long period of time. Eventually, they separate from each other. But while they're still lingering together, we see them as what we call an open star cluster. There's no pattern to them. There's just, can be hundreds of stars in the cluster. But the unique thing about them is that they're all relatively the same distance away and relatively the same age because they all formed out of the same cloud of gas and dust. And because of that, and the other thing is because they all formed out of the same cloud of gas and dust, their composition is relatively the same. So same composition, same age, same distance. So any differences that we see in the appearance of the stars is intrinsic to the stars. And the cool thing about that is that it allows us to better understand stellar evolution. If a star is a big, massive star, it's going to shine very bright and it's going to shine very hot. A much smaller, low mass star is going to be cool. It's going to be yellowish in color. All these properties of the stars are intrinsic because there's nothing else that can cause those variations. And by using that information, we can sort of look at stars at different periods in their lives for different stars based on their masses, and use that to sort of determine what the typical star life is like and what processes the stars go through. It really helps our understanding of stellar evolution. And a lot that we know about stars today, about how they're born, how they live, and how they die, is based on the study of open star clusters like Messier. What is it? 52, right? Yeah, right. Okay.
Yeah.
Okay. Let's see. I think our next object.
I have 103.
Is 103.
103. Yeah. Yes. And I don't have an image of 103 either.
Let me see if I've got something here.
So M103 is about 8.5 or 8,500 light years away. It's another open star cluster, also in Cassiopeia.
Let me see if I've got a photo of that. I do. Hold on.
All right.
Let me share my screen. I do, such as it is. So there it is.
Yeah.
There it is.
It's not a real exciting one.
It's not a very exciting photograph, but this is another one though that's very easy to find. And if I let me zoom in here on the star map a little bit, so you could see that the second star, here's the first star, here's the second star in Cassiopeia of the W is right next to M103. So if you point your telescope at this bright star here and just jog it over just a tiny bit, you'll be right on M103. And that's all you really need. Oops, sorry. That's all you really need to do to star hop to it. Let me put it back here. Sorry. I'm showing you a spectrum of M103. There we go. Okay.
Okay. So the next object is called Messier 76. It's also known as the Little Dumbbell Nebula. And
yeah.
again, I don't have a photo of it, but hopefully you can find one. And
so that's
Messier
76.
Messier 76 is what we call a planetary nebula. And several of the objects we're going to be looking at tonight are planetary nebulae, so I should explain what they are. Most stars, when they reach the end of their lives, they don't die in a supernova explosion. Contrary to popular belief, actually fewer than 10% of all stars blow up in a supernova at the end of their lives. Most stars die in a very slow process where they swell up, they become red giant stars. They go through a series of pulsations as helium is fused at the core. They slowly, over thousands and thousands of years, blow off their outer layers of the star. And like I said, this goes on for thousands, sometimes hundreds of thousands of years. And as that happens, it slowly exposes the inner hotter part of the star. Eventually, what happens is the fusion process, which is the kind of the engine that drives the star and produces the heat and everything at the center. The fusion process stops. When that stops, you no longer have outward pressure. Gravity causes whatever's left of the star to collapse into what's called a white dwarf. White dwarf is very small. It's very compact. So you had a star that was maybe once the size of our sun or even a little bit bigger, and now it has collapsed down and it's maybe the size of the Earth. So you've gone from 1 million miles in diameter to 10,000 miles in diameter. The white dwarf is extremely compact. It is highly condensed matter. Something like a teaspoon will weigh as much as a Mack truck or more. And it is what we call degenerate matter. So what's happening is the electrons can't bounce to new energy levels. They're kind of squeezed too tightly. And there's a lot of heat in a white dwarf. It's all the residual heat left over from the star. And because it's so compact, it sort of retains that heat for a very long time, slowly cooling over literally billions of years, maybe even trillions of years. And eventually it runs out of all that heat. As it does, it cools and becomes, instead of a white dwarf, what we call a black dwarf. But it's likely that no white dwarf that has formed since the beginning of the universe has reached the point where it's a black dwarf yet. It takes a long time for that to happen. So that's kind of how our sun is going to end its life, and that's how most stars end their lives. When the star is still a red giant and it's blowing all that gas out into space, that gas surrounds what's left of the star. And when the white dwarf forms, it emits ultraviolet radiation, which ionizes the gas, causing the gas to glow. And so what we see with the little dumbbell and a number of the other planetary nebulae that we're going to look at is that glowing gas being ionized by the ultraviolet radiation from the white dwarf.
Uh, One of our participants shared a really nice version of M76. I'm going to show that right now here. Here we go.
In the meantime, M76 is one of the fainter Messier objects, and it's known as the Little Dumbbell Nebula, but it's also known as the Cork Nebula, the Butterfly Nebula, and the Barbell Nebula. Got a bunch of names.
Yeah, that's
I guess.
This is actually one of the nicest photos of M76 I've ever seen. I've always been rather unimpressed by most of the photos I've seen, but this is quite nice.
Very faint. Oh, that is nice. Yeah.
And again, you could see, the red areas are hydrogen, and I mentioned earlier hydrogen alpha, where hydrogen is just starting to get ionized. And the blue represents oxygen. And as Gerald has pointed out several times in the past, the hydrogen content far outweighs the oxygen content, but the oxygen just glows brighter. So it tends to exaggerate. These images tend to exaggerate the amount of the amount of oxygen, but makes for very nice photographs.
Okay.
Yep.
Well, the next object is M34 in Perseus. It's another open star cluster, and it's another one that I don't have images for.
Let me see what that looks like here. I do have one here.
M34 is about 1,400 light years away. It's got fewer stars than some of the other open star clusters that we're going to look at. So there it is. M34.
Yep. And again, you can see in Perseus, the way to star hop is to look for this bright star right here and just kind of head down towards the constellation below. This is Castor and Pollux down below, and just go down. And
it's not Castor and Pollux.
Is that Castor and Pollux? No, that is.
No, that's Andromeda.
That's Almach and
and
Nimbus. Sorry.
Yeah.
And you just kind of head right for the middle in between, and it's in a straight line to get to M34.
Yeah. Interestingly, this was not discovered by Messier. It was discovered 100 years before Messier by a guy named Giovanni Battista Hodierna, I believe it is pronounced.
Say that 3 times fast.
Yeah, right. So,
I've heard his name before. He discovered several other notable objects, and I'm trying to remember what it is recently we were talking about that he had found. I can't remember, but there was a previous evening where his name came up.
Okay, well, our next object, let's see here. Our next object is a cool one. The next object is
yes,
an object you can see with your naked eye. It's called the Pleiades, also known as Subaru. So hang on just a second here.
No more car jokes tonight.
Yeah.
Putting a kibosh on that.
So here it is. So the Pleiades is an open star cluster. It's in the constellation Taurus. It's about 420 light years away. I know SEDS says a little bit farther, but recent data says it's a little bit closer than what SEDS says. It's about 420 light years away. These are all stars that formed out of a cloud of gas and dust. Now you can see some nebulosity around all these stars, And earlier we thought, well, that's still the remnant of that cloud that they formed from. Well, it turns out that's not the case. It turns out that as these stars were drifting around the galaxy, they passed through another cloud of gas and dust. So the cloud that you see, that nebulosity, is not the original cloud of gas and dust from which these stars formed. It's a new cloud of gas that the stars are passing through. And again, this object you can see with your naked eye when you look towards the constellation Taurus. It looks like a little miniature Little Dipper. And we call it the Pleiades. Sometimes we call it the Seven Sisters. The Pleiades were seven sisters in Greek mythology. In Japan, they call it Subaru. And if you look at the emblem on the front of a Subaru car, you will see a star pattern, which is reminiscent of the Pleiades or the Subaru star cluster.
So you can see what Gerald was talking about. Here's Taurus, and you always look for the triangle here. And if you go over to the right and down a little bit towards the west, it'll be very, very obvious. It's a naked eye or binocular object easily.
Oh yeah, it looks great in binoculars.
Yeah. Very, very good.
Yeah.
Binocular
Sorry, I was
image,
wondering if they had a photo in the sky, and they don't, which is funny. All right.
Really? They got everything else, but they don't have.
They got everything else. Yeah, they got obscure little open clusters, and it's like here's this big beautiful thing, and they don't have a photo.
Yeah, I have a photo.
Go ahead and share it.
I'm about to do that. Let's see here. I can't get this.
Is this your photo?
Working on, no, this is from SEDS. Looks like the photograph is from David Mallon, but for some reason
okay. Inventor of the Mallon cam.
Oh.
That's right. I wonder if he took this with a Mallon cam.
Yeah, well, we won't comment.
I'm having a hard time here.
All right. Well.
Yeah, well, why don't we move on? Our next object
okay.
is a different kind of star cluster. This is the object M79. And let me share my screen here and show you an image of it. This is what we call a globular star cluster. So before we were talking about an open star cluster. In an open star cluster, the stars are just kind of scattered randomly. In a globular star cluster, the stars are sort of concentrated, kind of in like a ball-like structure out in space. And this is one of them. This is actually one of the less dense globular star clusters. And what's unique about this is the stars that you see are actually orbiting around the center of the cluster. And they orbit in these long elliptical orbits, and they go in, and when they get in close to the center, they're moving very fast, and then they swing out and they slow way down, and then they come back in and speed up and keep doing that. So it's very dense, especially near the center. If you lived on a planet orbiting one of these stars near the center, you wouldn't have a nighttime because there would be so many stars so close to you. It would kind of just light up, be like having dozens of full moons in your night sky. It is 42,000 light years away, and it is one of 150 or more globular star clusters that orbit around our galaxy. Now, these, when you look at our Milky Way galaxy, it's a flat disk with spiral arms in it and a central bulge, but the globular star clusters aren't in the disk. They are in what's called the halo, which is a region that surrounds the disk. And so they're either above or below the disk. And because of that, they don't get mixed up with all of the gas and dust where all those new stars are forming in the disk of the galaxy. These guys are up away from all that gas and dust. So there's no new gas and dust to form stars in globular star clusters. And the result is all of the original stars that formed in the globular star cluster that were greater than the mass of the sun, those stars are all gone. Globular star clusters are very old. They're somewhere around 11 or 12 billion years old. And a star that has 2 or 3 or 5 or 10 times the mass of the sun, it doesn't live that long. So the high mass stars that were part of this cluster originally, they have all reached the end of their life. They've gone. They've either become black holes or neutron stars, blowing themselves up in supernovae. They're all gone, and all that's left are the lower mass stars. Low mass stars are the ones that live long times. Our sun is going to stay in the main sequence for 10 billion years, and probably its total lifespan is going to be 12 billion years. Stars that are even lower mass than our sun will last much longer. These stars that you see are probably among the first stars to have formed, at least when our galaxy was forming, and maybe among the first stars to have formed when the universe itself was being born.
So once again, I searched for M79 without qualifying for astronomy, and I came up with a list of grenade launchers. So hold on. M79. I'm just lazy. I don't want to keep typing Messier after that. And
this is
these weapon systems.
This is another object that was discovered by Messier Marathon.
Yep.
And if anybody out there speaks French, I hope we're pronouncing his name.
We're destroying the pronunciation.
Probably.
Messier.
Yeah. He was a colleague of Messier and reported a lot of his discoveries to Messier.
So this one is about 42,000 light years away from Earth and 60,000 light years from the galactic center. That's what I was looking for, where the distance is.
I think I already gave the distance, but that's all right.
I think you did.
Yeah.
Okay, well, that's M79. The next object on our list.
Ought to be very familiar.
Yes. Next object on our list is M42, the Great Orion Nebula. I'm going to bring up an image. This is a Hubble Space Telescope image, and it's a low-resolution version of the Hubble Space Telescope image. There it is right there. And I say it's a low-resolution version because the Space Telescope Institute, which is the organization that runs the Hubble Space Telescope, they created a high-resolution version of this image. It's over 70 megabyte image. And what's really cool is you can zoom way in. Now you can zoom in a little bit on this one, but
that's nice.
So you see here 4 stars. These are what we call the trapezium stars. And if you've been watching us over the last couple of months or a couple of weeks anyway, we've talked about M42. It's in the constellation Orion, and it's up right now. And it's a favorite object for amateur astronomers to photograph because it just shows up really well. These 4 stars are called the trapezium stars. They're hot O-type stars and B-type stars, massive stars that produce a tremendous amount of ultraviolet radiation and energy. They are big, massive stars. They burn very hot, and that means they won't last very long. So these stars are probably not even 1 million years old, but they've already reached the point where they're emitting so much radiation that they're blowing the gas away from the stars. So they formed from this huge cloud of gas and dust. And now that gas is being pushed away by the energy from the trapezium stars. Now, embedded within this cloud are many more lower mass stars that are still in the formation process. And in fact, the pressure of the ultraviolet radiation from these stars is actually causing the cloud to condense and causing even more stars to start forming. So this whole region...
Give you a little bit of sense of that from the RGB image that we took. So this was taken from Nellie a few weeks back, and you could see all of the little stars here. These are all star forming regions, and what Gerald was talking about is how they're emerging from these clouds. You don't see that as much in the vivid color image that Gerald was showing, because that's a narrowband image, and it's looking specifically at the glowing hydrogen, oxygen, and sulfur gases, whereas this is a red, green, blue image and is more sensitive to the starlight from the emerging stars.
Interesting, the trapezium cluster was found as a multiple star by Galileo in 1617.
Little
It goes
sharp-eyed
way back.
Galileo.
He did have a sharp set of eyes.
Yeah.
Okay. Well,
great.
Our next object is called Messier 43. And this is another star-forming region, a cloud of gas and dust that is condensing to form new stars. Got an image here for you to see. This is a Hubble Space Telescope image. And you can see a similar effect here. Here we've got a very hot star, very young star, massive star that's producing so much energy that it's starting to push the cloud away from it. But you can see dense clouds of gas here, and new stars are forming within this cloud. And what's going to eventually happen is the cloud will dissipate, leaving behind hundreds, if not thousands, of new stars that formed from this cloud. This one is also about 1,300 light years away, maybe a little bit more than that. It's called Demarin's Nebula, and it is a companion to M42, the Great Orion Nebula that we were just looking at. So these two are right next to each other.
And so it's Demarin's Nebula because Demarin, Jean-Jacques Dortu Demarin,
just for you to say,
discovered it before 1731. So it was in the very early 1700s, and it was cataloged by Charles Messier, but he wasn't the discoverer.
Right. And I'm sure you pronounced his name right.
Oh, I'm sure it was perfect French. Yeah.
Okay, what's our next object? I believe it's M78, right? Yeah.
Yes.
M78 is also associated with the Orion Nebula. I'm not sure if I have an image or not. No, I do not.
Let me see if I've got one. It's so terrible that I don't even want to show it.
Let me try what I have again.
Yeah.
Let's see. You see that?
Yeah.
Yeah.
That's not a great image, but
it's better than the one I had. Yeah. There you go.
Okay, so what can we say about, well, we've always said it's associated with the same.
Well, this is a little bit different. This is a reflection nebula. And a reflection nebula means that, well, I guess that's not all that different, because a reflection nebula means the gas is being illuminated by stars that are either embedded or adjacent to the gas. The gas itself isn't glowing intrinsically.
Right. All right. Let's see. Our next object is one that's a very popular object, M1.
Hey.
The Crab Nebula.
Yes.
And I do have an image of M1. I'll share here with you in just a second.
Another very faint nebula.
One of the most interesting to look at, though.
M1 is the remnant of a supernova. This was a massive star, and it exploded in a supernova. And what you see is all of the material blown off this exploding star. Interestingly, this supernova was actually seen by human beings in the year 1054 AD, or as we say, CE nowadays. and it was seen so bright that they could even see it in the daytime. And this is a star. It's about 6,300 light years away from us. And like I say, it's an exploding star, supernova. And it's got all kinds of interesting elements in it, heavy elements that were produced during the final stages of that star's life, and produced during the explosion itself. And it's those heavy elements that eventually seed other stars and create more heavy elements in newer stars that will form from all this gas and dust that you see blown off of this star. So this gas and dust will spread out, dissipate into space over millions and billions of years, eventually come together with other gas and dust from other exploded stars, and will condense and form new stars. And because the exploding supernova produced all these heavy elements, that new star will have more of those heavier elements than previous generations of stars.
Now, the other interesting thing about the Crab Nebula, or M1, is that the remnant of that supernova explosion is a neutron star. And that neutron star is spinning very, very fast. And every time it does a rotation, it sends a pulse of energy towards the Earth that we detect in radio telescopes.
Yep.
And it's called a pulsar. And every pulsar has a different rate of rotation, and it's kind of like its fingerprint. And you can actually listen to those radio pulses. There are various websites which allow you to play those back. It's kind of interesting. Let me show real quick where it is. Again, this is an easy object to find. The problem is that it's pretty dim. However, I've looked at it in from neighborhoods in Oakland with a 4-inch telescope. It is possible to see it with a modest telescope. And what you do is you look for this bright star in Taurus. You see how Taurus has this big arrow, right? You see this whole thing as a giant arrowhead in the sky. And this star here is called Alheca. And if you go a little bit over from that, you'll be looking right at M1. And that's all I got to say about hopping to it.
All right. Well, let's see. Our next object, which I don't have an image of, is called M35. It's another open star cluster, new stars that formed out of a huge cloud of gas and dust. It's in the constellation Gemini. It's about 2,800 light years away. Unfortunately, I don't have an image of it. So
let me see if either John or I have.
I have one I can show. It's not too bad. Let's see.
Yeah, you should show yours.
There we go. You see it?
Yeah. That's
okay.
Good.
Yeah.
That's a really good one. Yeah.
So we're going to do, I think, a couple of open star clusters in a row here.
Yep.
Okay.
So next is
M37. Yeah.
Oh, this is a good one.
Yeah.
Yeah, man, this is a good one. Unfortunately, I don't have an image of it, but I'll bet you guys do.
Yeah, let's go with John's. He's on the SEDS database. They have a lot of good images.
Yeah, okay, let's go for it.
Yeah, M37 is a pretty popular object for us to look at with our telescopes up here at Chabot when back in those days when we were doing public viewing, and hopefully we will be doing that again later this year. It's about 4,400 light years away, and it's another one of those open star clusters, stars that all formed out of a huge cloud of gas and dust, and the gas and dust is now dissipated, leaving behind hundreds of stars that are drifting together through space. Now, an interesting thing about open star clusters is they are in orbit around the galaxy. but because their distance from the center of the galaxy is not exactly the same, there's small differences in the distance. But the laws of orbital mechanics are such that the closer you are to the center of the galaxy, the faster you orbit. So the stars in a open star cluster like this, they're a little bit closer to the center of a galaxy. They're orbiting a little faster, and the ones farther away are orbiting a little slower. And what that does is over time, it sort of stretches out and eventually separates all the stars. And the other thing that happens is as they orbit around the galaxy, they periodically pass through clouds of gas and dust. There's variations in the density of those clouds of gas and dust, and that further causes the stars to sort of separate from each other. So eventually these stars are all going to dissipate, or not dissipate, but spread out and become separate stars. Our sun formed in an open star cluster similar to this. Now you can't see it in this image, although, I can tell where it is. But
There's no color in this image.
Yeah,
That's what you're talking about. Yeah.
yeah. So there's one star that when you look at this through a telescope, there's one star that's much brighter than the rest of them. It's orange in color, and it really draws your eye when you look at it through the telescope.
It's right near the center, and it just stands out. Yeah.
And it's not part of the cluster. It's
That's
actually
right.
closer to us. So okay. So that's M.
Let me show a picture where you could find this, if you don't mind. It's
Yeah, because it's a fun thing to look at.
yeah, not everybody knows where the constellation
Easy.
Auriga is or what that constellation looks like. It's I remember when I first got into astronomy, I was like, Auriga, I've never heard of that. And so Auriga is a prominent winter constellation, and it's notable by having these 1, 2, 3, 4, 5, really 6 bright stars and kind of a trapezoidal, not trapezoidal, a pentagon shape. And M37 and M36 are both notable open clusters in Auriga, and M37 is just outside the boundaries between these two bright stars. And this one here is Elnath, and this one here is Bogardus. And this is the bright one, which is Capella, which is the more well-known bright star in that constellation. So Bogardus and Elnath and M37.
Okay, well, our next object is very close to it. This is M36, also in Auriga, and also an open star cluster. It's a little bit closer to us, about 4,100 4,100 light years away. 4,100 kilometers, we're in trouble.
Yeah,
we're in the middle of it.
That's all right.
Yeah, 4,100 light years away.
So this is another cluster discovered by Hodierma in 1654.
100 years before Messier.
100 years before Messier. Exact. Yeah, 110 actually.
All right. What all can we say about it? We've given the distance.
Other than that,
yeah.
Not a whole lot here.
Yeah, we're going to be showing you a lot of open star clusters, so we're going to run out of things to say about them other than to show you a picture when we can.
It's actually one of the things about that. I don't know if you have a picture of M36, John, but the M36 is compared. Yeah, why don't you show that? M36 is compared to the Pleiades cluster, and due to its similarity in composition. And if it was the same distance from us as the Pleiades, it would look very similar. But you can see how it's got some, very bright stars surrounded by much dimmer ones. But I'll bet it has more than 7.
Well, so does the Pleiades.
Yeah, it would have been a tougher logo for a car.
Right.
Yeah. So the next one is yet another open star cluster in Auriga. It's M38. and I don't have a picture of this one either. So.
Your open cluster poor over there, Gerald.
Yeah, I
And
know.
guess what? This was also discovered by Giovanni Hodie.
That's why I don't have any pictures.
And it looks
you
a
don't have
lot
any
like the others
Hodie
too.
Yeah. Well, that's the thing about open clusters. After a while, they all kind of look alike.
Yeah. And the next object is also an open star cluster. So.
Okay, I'll stop sharing
Okay.
that one.
Okay, so just to remind everybody, we're doing a Messier Marathon. We're looking at all of the Messier objects in the night sky. There are 110 of these objects, and they are spread across the whole sky, mostly in the northern part of the sky. And we are taking them in order as we would see them if we were actually observing them tonight. Unfortunately, our weather is not cooperating, so we're having to just show you images and talk about these objects. So we apologize for that, but Mother Nature had other ideas tonight.
And these are grouped by location, so they're all different kinds of things, different objects, different kinds of objects. Not in any order here.
Okay, our next one is M41. Messier 41 is yet another open star cluster. It is 2,300 light years away.
It's in a different constellation. Yeah.
Yes, it's in Canis Major.
Yes.
The big dog. So if you're outside and you do have clear skies, if you look up and you see the constellation Orion, kind of down and to the left of Orion, there's a very bright star. It's the brightest star in the constellation Canis Major.
In the entire sky, actually.
It's actually the brightest star in the entire night sky, right?
Yep, and there we go. And that's where you'll find our object, Messier 41.
Yep. So let's see, I believe our next object is M93 in the constellation Puppis, which M93, yet another open star cluster.
Another open cluster.
You're going to start to think that we're repeating ourselves here. Let's see, this is now that's not M93, that's M95.
Do you have a photo of M93?
No,
John, do you have one?
Yes, I'm bringing it up
Right.
here just in a second.
So this M93 is about 3,600 light years away. It is in the constellation Puppis, which I believe is a southern constellation, right?
Yeah, it's pretty far
we can
south.
see it. We can see it from the northern hemisphere, but it's very low in the southern sky.
It's the bunny rabbit, is it not?
No, you're thinking of Lepus.
Oh, that's right. That's right. That's right. Yes. Oh, sorry.
That's okay. Yeah. But one thing is certain, Gerald seems to be open cluster poor over
Yes.
Yeah.
Obviously, he likes taking pictures of other things.
Yeah, we all kind of do. Yeah.
And while we're in Puppis, the next object is M47, which is also an open star cluster in Puppis, and I don't have an image of that.
No, M47 is M47 is not an open star cluster. It's cataloged as an irregular galaxy.
What?
According to the sky. So let me look this up in greater detail.
It looks very irregular.
It's called an open star cluster, and
yeah, it says open cluster here. So it's a bug in the sky's database. That's interesting.
Never happens.
That's really good. I'm gonna have to write that one in.
So this one is 1,600 light years away. I don't have an image, so John, if you can find one, that would be great.
There we go.
All right. So definitely not a galaxy.
Definitely not a galaxy. Yeah. Now that I'm looking at the picture, I'm saying, how did they make that mistake?
Looks like a lot like the Pleiades, actually.
Yeah.
With some really bright stars in the middle.
Yep. So this is again in Puppis. And we've got one more Pupas one that we want to look at, M46.
That's an open cluster.
Yeah, M46 is another open star cluster. It is also in the constellation Pupas, but it is farther away. It's 5,400 light years away. And it's more diffuse. John, if you've got an image, I don't.
Coming up.
I'm continuing to be open cluster poor with my images.
This one's very open. I'm going to spread out.
Now, is that a
Not sure what that is in the middle there. That
a planetary nebula, like
don't
in
know.
the middle of that open cluster?
I see that, but I don't know whether that's just a spot on the picture or what.
No,
it's not
that's
explained.
M46. I need to look into this here because
Yeah,
that
it's
sure
interesting,
looks like
huh?
it's a planetary nebula,
Yeah.
but I don't recall ever reading about that. And I have a photo. Yes, it is. How interesting.
Huh.
Now, I would really like to. It'll take me a second, but it's worth showing this to people. Hold on for a moment. You could continue showing yours. I'm going to switch over to another photo.
Okay.
This is M46 Wikipedia. It of course brought me to the M46 tank. So I've got grenade launchers.
You need a military filter in there.
Yeah,
Really?
I do. Let me see if I can. Okay, I've got it here. Now let me come on, resolve.
3,200 light years away.
This is really actually pretty remarkable, and now it makes me want to go back and take a look at this. You could see in this image, it's actually flipped from the one that John was originally showing, but you could see that this is a planetary nebula here in the outer edge of the open cluster. And sometimes, we get we see things like that in the edges of globular clusters or in open clusters, and they may be part of the cluster or they may be foreground objects. In this case, I'm willing to wager it's a foreground object, but not in the cluster itself. But who knows? That's really interesting. Yeah, it doesn't say anything about. Oh, here it is. That planetary nebula is NGC 2438. And it appears to lie within the cluster on its northern edge, but is most likely unrelated to the cluster because it does not share the cluster's radial velocity. That means the cluster's rotation is happening at a different apparent rate than the movement of that planetary nebula.
Okay. All right.
Cool.
That is cool. Very interesting.
Our next object is called Messier 50, and it is in the constellation that I call Monoceros, and other people call Monoceros. So take your pick.
I'm a Monoceros. Okay. You're a Monoceros.
I'm a Monoceros.
How about just a unicorn?
It's a unicorn, right? Yeah. So Messier 50.
I say potato, you say potato.
So Messier 50 is another open star cluster. It's about 3,200 light years away. It was discovered originally by Cassini and then independently later on discovered by Messier. So there it is. Very much an open cluster. Probably those stars are already starting to kind of spread out a little bit.
Yeah.
So, all right. So what's our next object? Our next object is M48 in Hydra. M48 in Hydra, which is another open star cluster about 1,500 light years away. Does Gerald have an image? Probably not.
No, it should be one on the SEDS database.
Working. And okay, it's not a bad image. Let's show it here.
It's a pretty large open cluster. It fills the entire
Very diffuse,
it filled the entire telescope field in Herschel's scope. Yeah.
Yeah, very diffuse. So this is probably an older star cluster. So the stars are already starting to spread away from each other. And of course, it's closer. So even if they were close together, they would look farther apart because it's closer. All right.
Now, this wouldn't be the case here, but this is also considered a naked eye object, although I have never been in the right place at the right time to confirm that.
Maybe your naked eye, but not my naked eye. Okay, our next object, I think I definitely do have an image of. It is M45, also known as the Pleiades. Wait a minute.
Wait a minute.
Right?
No, we already did the Pleiades.
Yeah. Oh, M44. That's what I'm messing up here, which I do have an image of. Let's see. Yes, I do. This is called the Beehive cluster in the constellation.
Oh yeah.
Cancer the Crab.
Yeah.
Cancer the Crab. This is
right in the middle of the crab.
Now, it's called the Beehive cluster because some people look at this shape of it and say it looks like a beehive.
I know what's coming.
But when I look at it, I don't have the other image, unfortunately. But when I look at it, I see this shape here, kind of a roundish bottom and a triangular shape with a little flag coming off the end. And I think Hershey's Kisses. But it's officially known as the Beehive cluster. It's in the constellation Cancer, the Crab, and it's about 570 light years away. So it's relatively close, and this is yet another open star cluster.
Also considered naked eye, but I've never really seen it without binoculars.
Really? Yeah.
But binoculars do a good job on it.
So let's see what else we got. We got M67. Whoops, I'm screwing up here.
That's all right. We'll get you straightened out.
Yeah.
67 is next year, right?
Okay. And another open star cluster also in Cancer, the Crab. So let me stop my share here. I don't have an image of this one, I don't think.
I have one up here. I could show it.
Okay.
Stand by here.
Yeah, I don't have this one. So M67 is another open star cluster in the constellation Cancer. It is
fairly close, fairly bright.
2,700 light years away.
And this one was obtained by the Sloan Digital Sky Survey.
Really?
This was a project. That was a Microsoft project to create an online sky survey of the entire known night sky at pretty high resolution.
Gee, that's funny how it's all orange stars. Is that?
Yeah. That is
are they using some sort of filter or something to make it look that way?
I don't know. Let's see. It was all of its stars are the same distance in age, save for approximately 30 anomalous blue stragglers. And it's one of the most studied open clusters. And its age is estimated to be 4 billion years. It has more than 100 stars similar to the sun and lots of red giants.
Oh.
So that so those are the red giants.
I guess.
they're very numerous and they're very obvious. And you can see the blue stragglers as well. There's a lot of yeah, it's pretty neat.
One of the oldest known open clusters and by far the oldest of Messier's open clusters. Interesting.
Okay, our next object is Messier 95, a spiral galaxy in the constellation Leo. It's about 38 million light years away, and I do have an image of this one, so bear with me here for a second.
Yeah, Gerald, you're. Oh,
If
you guys cut out, so I don't know if. John, are you able to hear me?
Yes.
Yeah. Okay. I cut out for some reason.
Must be that really good internet connection you have there. So here's Messier
Yeah, that could be it.
95.
Yeah. Oh yeah, that
So
looks
this is
nice.
a Hubble Space Telescope image. It's not showing the whole spiral galaxy. It's just showing part of it. And you can see some of the spiral arms here. You can see that very dense central bulge with a black hole at the center of it. Very interesting object. Not quite straight on. Some images that I've seen of this suggest that it's a barred spiral. You don't see it here. Well, maybe you see the bar right here a little bit, but
Yeah.
Spiral galaxies often have what looks like a straight bar through the central bulge, and we call those barred spirals. And the spiral arms actually spin off the ends of the bar.
So that's acknowledged in its designation because the classification is SBRB and rather than
Bar,
SBB.
yeah,
So it's got the bar, but the R means it has an inner ring surrounding the bar.
Huh.
So that's what obscures it a little bit.
Yeah, there's all kinds of technical details here. When you see designations for spiral galaxies, you don't just say it's a spiral galaxy. You have a classification system that we use. So, guys, we've been talking away here, and I'm not sure if we're not missing questions and things coming from our audience. So it might be good to just check and see what kind of comments and questions we're getting.
Yeah, we got a couple. Kramer just asked, are the bars gas clouds? Well, not really. The bars are. Can you guys hear me? Because again, we're cutting out here.
Yeah, I can hear you, but you're a little faint.
All right. Well, the bars are caused by black holes. Actually, a pair of black holes usually in the center of the galaxy, and it creates a gravitational anomaly in the center where you've got two very powerful gravitational forces that are distorting the orientation of the stars towards the core of the galaxy, and it gives it a bar-shaped pattern.
Yeah, we've had a few latecomers. Again, we are not observing through the telescope tonight. We're just going through images of the Messier objects.
Yeah, we're trying to do a Messier marathon without actually looking at the Messier objects.
Yeah. So. In other words, we're double cheating. Not only are we sitting next to a computerized telescope, but we've even ditched that, and now we're just looking at images and star maps. So,
yeah. Unfortunately, the weather is just not cooperating for us tonight. The humidity is too high, and it's overcast.
And windy and cold.
And cold, yes.
Yeah, so we just looked at what M95.
We were talking about taking a short break before 9 o'clock. Did you want to do that?
I think we should. When we take a short break, if you guys need to take a break, and we've still got a few questions we can catch up on. Cadillac Black just asked, where can I go to see the Milky Way in the Bay Area? And when is a good time to go? Well, yeah, we get that question a lot. And it's hard to see the Milky Way in the Bay Area because the Milky Way is not, it's huge, but it's not terribly bright. So it gets washed out by city lights. So I find that the best place to go to see the Milky Way is to get a couple hours outside of the city, go up to like Lake Sonoma, or if you head south into Monterey County, there's a park called Fremont Peak. A lot of people go up there who are into astronomy. You can head over to the San Luis Reservoir at night, and it's dark enough there to see the Milky Way. If you go to Mount Tam or Mount Diablo on a clear night, you'll see a bit of the Milky Way. You'll see a bright band or a brighter band of stars than you normally would in the city. But to really appreciate it, you've got to go someplace really dark. And of course, the best views of the Milky Way are getting way out of the city, like into the Sierras and Yosemite and places like that. Then it's really obvious. Somebody said, "Come to New Zealand. You'll see it there." Sure. Yeah, all right. Send me a plane
Sure.
ticket.
Love
Right.
to, unfortunately.
And of course, Richard said the best time is during a blackout. Well, well, who knows? Maybe rolling blackouts are our next crisis. We'll see what happens. Let's see what else we've got. Oh, and thank you all for your donations tonight. I really appreciate that. Looks like you guys have been doing really good answering the questions as they've been coming in.
Yeah.
People answer each other's questions, probably giving you better information than I would anyway. So it's all right. Yeah, the average age of the Jeremy has pointed out that the average age of the stars in many of these open clusters that we were looking at is around 4 to 6 billion years old, which means they're roughly the same age as our sun and have similar composition, and that is true. All right. Well, let's take a
Jerm
couple
says he's
of,
saving all his questions until 6 a.m.
Oh yeah, you'll be an audience of one at that point. I have a feeling. Okay, what time is it? It's 8:56. So we're going to take a 5-minute pause here, and I need to get a little more hot coffee into me, and
That
we'll
sounds
keep
really
an eye
good.
on the questions. Yep.
I'm gonna go ahead and mute my mic here.
All right. Many thanks to our EAS treasurer, Rebecca Arntz, for providing us with freshly baked brownies tonight. And these are really fantastic. So don't worry, we're not starving. I'll find out in a few minutes. Stephanie now pays attention when she heard brownies. Come on down. We got lots of brownies. They are really good brownies, made from good bittersweet chocolate. All right. Start up again in about a minute here.
So I often see Erica talking about Stephanie. I guess Stephanie is Erica's daughter. Is that right?
I would say that's a good guess.
Yeah, I know Stephanie has a moniker for me. She calls me the space guy.
That's a good moniker. That's about right. That's what
It's
we call
better
you
than some of the ones I've been called.
Well, Erica, you'll both come again post-pandemic. How about that?
There you go.
Apparently, she's 6 years old.
Oh,
All right.
all right. Well, Stephanie, when we reopen Chabot, I want you to come up and look us up, and we'll say hello and shake your hand because we really are glad to have you up here or on the air here watching us and throwing some questions at us and stumping us once in a while. So
Yeah.
We'll
I'm,
give you
uh,
a good view through the telescope, too.
I am going to look forward to meeting Stephanie. Okay, are we
All
ready
right. Where
to
are we?
resume?
We were just on M95.
Well, let's first
Yeah,
of
we
all,
are. Next is
before we,
M96.
yeah,
right?
before we resume, I think
Oh,
there's
yeah.
some people who are joining us just now, our usual 9 o'clock crowd, and probably wondering what the heck is going on here. So we are in the middle of what's called a Messier Marathon. Charles Messier was a French astronomer. He made a list of objects, about 104, what were faint fuzzy objects for him and his telescope. Today we still use that list. We call it the Messier Catalog. There are 110 objects on it. And every year around mid-March, it is possible to see all 110 objects in the night sky. If you start looking right after sunset and stay up all night, you can see all 110 objects. So that's kind of a fun thing for astronomers to do, is do an all-nighter and try to see all 110 objects. Now, unfortunately, because of the weather here at Chabot Space and Science Center, we are not able to do this with our telescope tonight. We had planned to put a couple of cameras on the telescope and actually do live views of all 110 objects, but that's not going to happen because of the weather. So what we're doing is showing you images from different sources, some from Hubble Space Telescope, some from other sources, and just kind of going through the objects as if we were doing the Messier Marathon. So we're taking them not in numeric order, but in order as we would see them across the sky if we were to do this over the course of a whole night. So we just did Messier 95, which is a spiral galaxy. Messier 96 is our next object. It too is a spiral galaxy, and it is also in the constellation Leo. It's 38 million light years away. And I mentioned this before, but I'll mention it again. We often see galaxies in clusters. So they're kind of grouped together, and there are a couple of these clusters in the constellation Leo. So Messier 96 is very close to Messier 95, the object that we were looking at a few minutes ago. And I'm going to try to share a view of Messier 96 here, if I can. Hang on just a second. All right, there it is. So this is
Very nice.
Messier 96. This is a Hubble Space Telescope image. It's another spiral galaxy. You see the spiral arms extending out. What's interesting about this is that there's two spiral arms, one coming out going this way and one coming out going this way. And the origin of this one is hard to pick out. The origin of this one is easy to see, but this one, it's kind of there, but it's pretty hard to see. Again, this is about 38 million light years away. It was discovered by our friend Pierre Méchain, or however it's pronounced. Somebody out there with a French background is really going to take us to task before this night is over.
Oh,
Yeah.
I would imagine.
No doubt.
Yeah. So anyway,
We're lucky to
this
get Messier pronounced right, I think.
Yeah.
right. Yeah. So this is again M96. All right. You got anything else about it?
Not much.
It's a good object.
You're going to show us where it is in the sky, aren't you?
Yeah, I could do that. It's a good object to look at with about a 10-inch telescope. That's kind of ideal for a. Let me go ahead and get this on the map and share my screen. So M96 is in the constellation Leo, and Leo is kind of galaxy central. I mean, that's this time of year, Leo is prominent in the sky, and it is filled with galaxies. The reason you're able to see so many galaxies in Leo is not because that direction is particularly abundant in galaxies compared to the rest of the universe, but it's because it's well enough far away from the Milky Way that the zillions of stars in the Milky Way don't obscure our view of those distant galaxies. We're kind of looking through the less populated part of our own Milky Way and allowing ourselves to see beyond the Milky Way into the more distant universe. And Leo happens to be a constellation that's in that direction with respect to the Milky Way galaxy. So anyway, that's where you'll find it. And
Okay.
Leo is notable for this. It doesn't look like a question mark in this orientation, but you could see this shape here. That's what you look for in the sky, is this thing that kind of looks like a giant question mark.
Big bright star at the bottom of it.
Backward question mark.
Backwards question mark. Yeah. And this bright one here, that's right, is
Regulus.
Regulus.
Yes. All right, very good.
Okay, our next object is also in Leo, also part of this kind of grouping of galaxies we see in Leo, is called Messier 105. Another galaxy about 38 million light years away. This one, though, is an elliptical galaxy. And unfortunately, I don't have an image of it, but perhaps you guys have an image.
See what I got here.
I've got one,
Okay.
and it's a particularly interesting
It's
one.
not a
and
real
I'll tell
big
you-
one. It's smaller
Yeah.
than some of the other galaxies there. So
The last three that we looked at are called the M96 group. There's those three galaxies.
All
Right.
right. So you guys see this?
no, there it is. Yep.
Yeah.
Yep.
Now I'm also seeing what appears to be like a jet
A jet. Yeah.
coming out from the. That's often caused by a very powerful electromagnetic source in the center of the galaxy, and in this case, most likely a black hole. And
A black hole of
and
about
it's
50 million times the mass of the sun. So this is a huge
That's
black
right.
hole.
And
Yes.
by a huge black hole, and it creates these these plasma jets that are cast into deep space for hundreds of thousands of light years, and it's remarkable. And we've actually seen that through Nellie as well. What was it? It
Yep.
was
Yeah.
not in this particular galaxy, but it
No, I
was.
think was it
It,
M87? I think it was,
was
or
it,
I
it
can't
was.
remember.
Yeah, I'm sorry, I forgot the number as well. But we were able to capture one of these jets once. It was
Yeah.
quite interesting.
Yeah, I'm trying
Oh,
to
maybe it was
figure.
M6. Maybe it was M64.
Yes, M60. Well, no.
See.
M64 is the black eye.
Oh yeah. Okay. All right. Well, let's not
Yeah,
guess. If it comes to us, we'll get it.
Yeah. Someone will probably
yeah.
tell us anyway.
Yeah, somebody will tell us. Yeah, tell us what we did last week.
Okay, so our next object, staying with the galaxies in Leo, is M65, another spiral galaxy in Leo. And I do believe I have an image. Yes, I do. Okay. It's only a partial image, so you'll have to bear with me a little bit here. There it is right there, M65. We might have a better image somewhere else. This is a Hubble Space Telescope, and because of the size of this, Hubble can't get the whole thing in its field of view. So what they do is they take multiple images, producing a mosaic. And I mean, this is a really dramatic image. You can clearly see this dust lane, gas and dust lane right here, and there's another one here. You can see the central core. This is a classic spiral galaxy, and it is part of another cluster of spiral galaxies, also in the constellation Leo.
I do have an image that shows the whole galaxy if you'd like me to
Yeah,
show that
please
at
do.
the moment.
That would
Yeah.
be great.
And while you're
Yeah.
bringing that up, Gerald, it was M87 with the.
That's what I thought.
Oh.
With the jet, yeah. And yeah, sorry, my apologies to everyone out there for the misinformation. I kind of excel at that. So
this image is turned sideways from the one that you just showed, but you can see that it's the same thing.
yeah, there's no up and down in space. So
Right.
That's right. That's right. All right.
Okay.
Well, our next object, also in Leo, is M66. And I do believe I have, yes, I do, M66. I've got another Hubble image of this spiral galaxy. And there it is. Again, this is just part of the galaxy because it's so big, Hubble can't get the whole thing in one field of view. M66 is 35 million light years away, and it actually was discovered by Charles Messier. And it is part of this group, what we call the Leo triplet, sometimes called the M66 group, which included M65 and another non-Messier galaxy that's also in the same group.
it's a really fantastic image.
Yeah. Yeah. Again, you see all these gas and dust lanes here. That's where all the new star formation is going on in here. And you can see hints of that. All these little red patches here, bright patches. That's where lots of new stars are forming. And this looks to be a little bit of a barred galaxy too.
It is classified as a barred galaxy with a weak bar feature.
Okay. All right. Okay, let's see what's next on our Messier agenda. M81. Oh, yeah, M81.
Oh, yeah, these are one of our favorites.
And I'm real sure M81 is also...
Otherwise...
Go ahead.
Go ahead.
Probably going to say the same thing.
Otherwise known as Bode's Galaxy.
Bode's Galaxy.
Yeah. Yes, everybody wants to call it Bode's, but his name is actually Bode. He's a German, and they pronounce that E on the end, so it's Bode. And I've got his galaxy here to show you.
I'm gonna fail in pronunciation tonight. That's for sure.
Johannes
Bode,
M81, another spiral galaxy, also known as Boda's galaxy. All right.
Boda's galaxy. I'll
Okay.
never say
12
that
million
wrong
light years
again.
away.
Yeah, 12 million light years away. Discovered by a guy named Johann Boda.
Ellert? Boda?
Yeah. So, all right, and again, you see lots of gas and dust lanes there where new stars are forming. Lots of spiral arms. This looks like it might also be a little bit of a barred galaxy as well. It's hard to tell. So that's M81. And I don't know if you guys got any other images that you want to share with us.
No, but I am looking for its
See what this
classification to
is.
see
Here,
whether
I have
It's
another
in the-
one. Let's
classified as
show me.
barred.
Let's show this one. Hang on a sec.
It's in the constellation Ursa Major, and it is right next to our next object.
Oh, let me guess. M82.
All
How
right,
did you
I'll
know?
Stop that one.
M82 is the one with the cool name.
Yeah, that one I'll pronounce properly.
Except we can't do it on television. We can't do an ad for it on television.
Yeah, right.
Yeah, that's right. But it's no problem on YouTube. All right. Did you have another image of M81, John, that you wanted to show? Or did
Oh,
you?
I put it up there for a bit.
Did you?
Not
Okay.
show?
Yeah.
Okay. All right.
No,
Well,
we're
our
good.
next
We'll move on to M82.
M82, which in the sky appears to be right next to M81, also in the constellation Ursa Major, also about 12 million light years away, and we call it the Cigar Galaxy. And let's see here if I can get it to come up. What's going on here? Oh, there's what's going on. And here's a Hubble Space Telescope image of it. Now,
Oh,
from this, you would not get the idea that it looks like a cigar, but I think John's going to show you another image here in a minute that makes
Yeah.
it clearer why they call it the Cigar Galaxy. But you notice all of this stuff blowing off of it. This is a huge cloud of gas and dust, and there's a lot of new star formation going on in here, and we're not quite sure why this is happening. And in fact, I was reading something the other day that it may actually be a foreground cloud of gas and dust.
Oh, really?
oh, really?
Yeah,
Just happens to line up perfectly with the
Right.
center.
Right. Now, with that color, what kind of gas was that got to be? It's got to be hydrogen.
Hydrogen.
Yep.
Okay.
Right. So,
So this was also discovered by Boda, right? In 1774.
yeah. Oh, there it is. Okay, so this is an image more typically of how you would see it in a telescope if you were looking with your eye through a telescope. And now you can see how they came up with this cigar galaxy.
Cigar name, yeah.
Yeah. And in fact, that dark band that you saw a while ago, it looks like the band that you often see around a cigar.
Yeah.
So for those of you who are cigar smokers, I'm not.
So the other theory, if that isn't a foreground cloud, it could be the result of gravitational interactions with M81.
That could be
That-
too. Yeah.
Oh,
That's
interesting.
another theory.
That's
That it's a tidal disruption,
That's an interesting theory.
but
All right.
who knows?
Okay. Well, moving on, I believe our next object is M97, the owl.
Who?
The Owl Nebula. All right, and I don't know. Stand by here. I'll see if I have an owl. No, I don't have an owl. So hopefully one of you guys has an
Give
owl.
it a shot here.
I've got one I've got to show. Hold on.
Oh,
I gotta show.
okay.
Okay, so
I gotta show the original drawing by Lord Ross of this
Okay.
nebula. Hold on for a moment here.
So the Owl
This is-
Nebula is what we
Hilarious.
call a planetary nebula. It's the remnant of a dying star. Once again, it's a star that grew old and blew its outer layers of
This is the original.
That's
This
great.
is the original drawing by Lord Ross, who gave the name Owl Nebula to this planetary nebula. But I've never seen this before. But I guess
Actually, when you see the photograph that I'm about to show, you're gonna understand why.
You go ahead and show the photograph, John. Go ahead and do that.
Yeah. You need to stop your share there.
Yeah,
I got it. Okay.
Yeah, okay.
Got it.
Okay, so this object is about 2,600 light years away. And again, it's the remnant of a dying star. There you are.
That's a little more honest representation there.
I don't know. I can imagine a lot of different things here. Owl is not one of them. But
Yeah. Wilson comes to mind from.
Wilson. Oh, yeah. The soccer ball.
Yeah, the soccer ball, yeah.
All right. Okay.
Very good.
So our next object is M108, another spiral galaxy. And I believe I do have an image of M108. No, I don't. I lied. Okay, so
M108.
M108 in Ursa Major.
I've got an image from the Sloan. I got an image here from the Sloan Digital Sky.
Yeah, yours is a much better image than I have, so go ahead with that.
Yeah, let me go ahead and share that.
Yeah, so this object's about 45 million light years away. It's nearly an edge-on spiral galaxy, so we're seeing it so that the disk is almost edge-on, not quite. And again, lots of gas and dust embedded in this galaxy where new stars are forming. All right, and again,
these types of images are really fun too, because you could see that there's another background galaxy, like right over here. Unfortunately, my cursor is a little bit obscured, but right over
there,
where my cursor, you could see all kinds of other galaxies. There's another one that I see elsewhere in the image. So these deep sky images tend to pick up quite a lot.
All right.
Very good.
So our next one is M109, M109, also in Ursa Major. We're getting a lot of Ursa Majors here. And
that's because we're in that part of the sky.
Yeah. This is 55 million light years away. It is definitely a barred spiral. And I don't have an image of it, but maybe we can pull one off of SEDS or something like that.
Yeah, it's not a terribly great one, but let's show it here. Oh dear.
Oh, there we go. So
that's very barred, yeah.
Yeah, we're waiting for Richard to come back on. Richard lost his internet connection, so
connection.
Oh, there you are. There you are. You're back. You're back.
Right.
All right. Okay, so this is a barred spiral galaxy called M109. It's 55 million light years away. It's in the constellation Ursa Major, the Big Bear. All right.
Okay.
And the next one is M40, I believe. Let's see if we can find M40. Oh, this is
favorite.
not. Yeah, this is how this ended up being a Messier object. Nobody can figure
Here,
out.
I'll share my screen with that one. Yes, hold on for a moment here. This is the most anticlimactic Messier object in the catalog. It's almost it's basically a double star, and I think that Messier probably looked at this through his telescope, and it probably had some kind of glow to it, and maybe there was some high clouds that night.
Might have been some high humidity in his telescope.
And high humidity, and yeah, exactly. And it looked like some kind of cloudy object, but in fact, it's just an ordinary double star.
I think he just had some bad French wine that night.
That could be it too. That's right.
So this object is also an Ursa Major, and we think one of the stars is about
Oh,
1,100 light years away, and the other one is about 450 light years away. So it looks
okay.
like a double, but they're actually far away from each other.
All
They're
right.
both on the
So
same line.
Rich Navarrete corrected us on something. Corrected. This is really actually pretty important in the historical record here. This was added in 1953. So
Oh,
I don't understand why it would have been added in 1953, but let's see. Oh, because Messier discovered it, but it wasn't part of his catalog. So it was discovered by Charles Messier in 1764. He was searching for a nebula that had been reported in the area by Hevelius, but not seeing any nebula, he cataloged this apparent pair of stars instead. But he didn't add it to his main catalog, I guess. So it was added to the popular Messier catalog in 1953.
huh.
So
So
there you go.
did they renumber the catalog in
Oh,
in
That's a good.
1953?
I that's a great question.
Hmm.
No, oh no, he's correcting himself now. He says no, M109 was added. So now you're just confusing me, Richard.
yeah, yeah.
All right.
Uh-oh.
All right, so it probably was part of the catalog originally as Messier 40, but it does have an interesting history in that he was trying to verify another astronomer's and a famous astronomer's observation, and really didn't find what the other one guy was looking for. Hevelius is known for his beautiful and classic
Star charts,
artistic
yeah.
drawings of the characters that the constellations represent, all of the mythological characters. You've all seen Hevelius's drawings at some point or another. That's spelled Hevelius, and it's worth looking up to see his artwork. It's really great. Anyway.
All right. Well, our next object is Messier 106, M106 or M106 in the constellation Canis Venatici, or sometimes pronounced Canis Venatici, which is, I believe, the
Hunting
fox.
dogs.
Hunting dogs. Yeah, that's it. The hunting dogs, right. It's 25 million light years away. Let me share an image here. It's another spiral.
You have it as
galaxy.
how far away, Gerald?
I have it as 25 million.
Yep.
Yeah,
that's right.
right.
That's right. Yep,
Yeah.
Yep. I thought you
You
said
think
something else. Sorry.
2,500?
No.
He thought she said zillion. Yeah.
Yes.
Now, what I find
It's
really
those-
interesting.
Must be those brownies. I don't know.
Yeah.
What I find really interesting is once again we have these massive disruptions here.
Yeah.
These huge clouds of hydrogen gas that have sprayed off of the main spiral arms. Something
yeah.
had to have caused that, and not sure what that might be. Maybe there's something in all of the text on SEDS or something that might explain that. And again, Canis Venatici and 25 million light years away. You finding anything there?
I'm not seeing it yet.
All right. I need to page down here. All right.
Well, one of the interesting things about M106 that might contribute to this is that it has an active nucleus. It is another Seyfert galaxy. So supermassive black hole, an X-ray source, and probably a very powerful jet, which might be blowing material out from the center and causing some of that disruptive gas structure.
Okay. The next object, really cool object, really cool image that we got here. This is Messier 94, M94. It is a spiral galaxy 14.5 million light years away, and I'm going to share a really spectacular image of it because it's a face-on spiral. Check it out.
Oh yeah, look at that.
Oh, nice.
Yeah, yeah. So you see a lot going on here. These spiral arms with the gas and dust clouds in here. Lots of older stars around the periphery. And of course, the central core. I'm not sure what the mass is of the black hole at the center, but this is just a really great image. And again, this is a Hubble Space Telescope image. And maybe we can find some other information about it, guys.
Yeah, it's a lot of really dense, detailed information. It's got what's called a low ionization nuclear emission region nucleus, and so that means it's weakly ionized gas in the center of that galaxy. And there's a lot of research being done on the outer spiral arms of this galaxy because they're very unusual.
Yeah. Look at.
And yeah, they look. This is a
There's
very
not
unique looking galaxy, and that's actually one of the main reasons this is a very heavily studied uh, uh, galaxy. And um, there was something I had just read that they're thinking that maybe its odd structure is due to the accretion or absorption of a satellite galaxy or
Okay.
gravitational interaction with some nearby object. But there were problems with some of those scenarios. And so they're just thinking that it's some internally created distortion in the galaxy's disk. So I don't know, a lot of hypotheses on this, but no real strong conclusion. But they do acknowledge it's a very different thing.
Okay. Well, the next object is the Sunflower Galaxy, Messier 63, another spiral galaxy, also in Canis Venatici. And let me share an image of it. There it is, sort of an angular view. Oops, I didn't want to do that.
This is another one with a low ionization emission nucleus.
Okay, I'm going to try that one more time here. So try to get the right image up here and share it correctly. All right, there we go. Okay.
Looks scary.
Lots going on. One of the interesting things about this image and the previous one is you can see a lot of individual stars, which is often very hard when you're photographing galaxies. You just see it as kind of a fog because there's so many stars, there's billions of stars, and they're so far away. So when you can see individual stars like this, that's pretty cool. M63 is called the Sunflower Galaxy. It's 37 million light years away in Canis Venatici. All right. Continuing on, we're at number 43 on our list of Messier objects. So we got quite a ways to go yet. And the next one is one of the coolest things you'll ever see in the night sky. M51. All right. So let me see if I can find my image of M51, which I know I have. And we'll see if we can't.
We have some good images of this taken through Nellie, actually.
Yeah, we do.
Yeah, we do. We've got a lot of good images here. Let me share this. This is M51. All right. One of the really interesting objects, easy to photograph in the night sky with a telescope. It shows up extremely well. And this is a spiral galaxy that's feeding off another galaxy. So you can clearly see that there's this other background galaxy here, and material is being drawn off into the spiral galaxy. Eventually, we think these two will merge. Um, M51 actually refers to the main spiral galaxy. The extra galaxy in the background here, that's called NGC 5194.
So if one is feeding off the other, is there an actual food chain of galaxies?
Well, yeah, sort of. Yep, yeah, there actually is. So
let me show
again,
you. Let me show you.
Yeah, I think you've got an image
Another
you shot
picture
with
here.
Nellie, right?
Well, no, that's not what I was going to show you. You remember a few minutes ago when we were looking at the Owl Nebula, I was showed you Lord Ross's sketch, and he
Yes.
also did one of M51. And I thought that this one isn't that bad, actually. And this is what he saw through his telescope. And where was that? Scotland? You know, like some terrible place to put a telescope, but at least it was close to home. And this was his sketch from the mid 1800s.
All right.
All right.
Okay.
Good sketch.
So, and one of the nice things about M51 is if you've got a modestly good telescope and put a camera on it, you can take pictures of this thing pretty easily. It's plenty bright and easy to take pictures of, and it's one of those kind of trophy images that you like to get when you're out doing astrophotography. All right. So our next object is M101, the Pinwheel Galaxy. And M101 is again in Ursa Major. So I believe I can share an image of the Pinwheel Galaxy, and you'll see why it's called the Pinwheel Galaxy. There you go. All right, so this is a Hubble Space Telescope image. The Pinwheel Galaxy is about 27 million light years away.
Also discovered by Pierre Michon.
Yeah, that guy was a busy guy.
He sure was.
Good thing he was a friend of Messier. So, it's in the constellation Ursa Major, and again, it's 27 million light years away. Yet another spiral galaxy. What's interesting when you look at this, you notice that there's actually only two spiral arms that come off the central core, 1 and 2. But those spiral arms split in several locations. So here's a split right there. Here's another split right here.
Oh, yeah.
And we actually think we have something similar going on in the Milky Way galaxy. So sometimes they're called spurs from the spiral arms. And we think that our sun is on one of those spurs of one of the spiral arms of the Milky Way galaxy. All right.
Cool.
Okay, let's see what's next on our list here.
Next one up, 102.
102. Okay, well, all right. Which is a lenticular galaxy, very unusual type of galaxy, lenticular. And yes, I do have an image. Now, interesting background to this. When Messier first put together his list, it appeared that he put the same object on his list twice. So the previous galaxy that we looked at was M101, and there's some controversy about this. It appeared that he actually had M101 on his list twice, listing it as both M101 and M102. But in later notes from Messier, he actually referred to a different object, and we're going to share this object here right now. There you go.
And even if it isn't the one he discovered, it's a great galaxy to look at.
Yeah.
Really
so
cool.
Here is a truly edge-on spiral galaxy. It is very flat spiral galaxy. We're seeing it edge on. And of course, that dark band that you see there, that's the cloud of gas and dust within the spiral arms. And then you can clearly see what's called the halo around the galaxy. That's where you find all the globular star clusters. And we haven't done much in the way of globular star clusters yet. We're going to get a lot of them here pretty soon. So this is M102, 45 million light years away. All right. If you guys have any other information, feel free to jump in here.
Not really, not on that.
Nope.
Pretty much said it all.
Okay, we're going to jump over to a different constellation now. And Coma Berenices. And we're going to start with M53. So let's see if I can bring M53. And like I say, we're going to start seeing a lot of globular star clusters. And M53 is, in fact, a globular star cluster.
Sure is.
And I'm not sure if yes, I do.
I do have one if you don't.
Yeah, I've got one here.
Really? Okay.
Yep, real nice Hubble
Good.
image. So there it is. This is M53. Now, you probably are thinking, wait a minute, didn't I see that a little while ago? No, but what you saw a little while ago looked very similar to this. This is, again, a globular star cluster. There are about 150 of them around the Milky Way galaxy, and a lot of them look very similar. You have to really study them to see the differences. Again, the stars in the cluster are orbiting around the center of the cluster in highly elliptical orbits. And those stars are all very old. Again, more than 10 billion years old. So most of the massive stars that form when the cluster first formed, they're all gone. And all that's left in the cluster are the lower mass stars, which live long enough to still be around. Because the globular star clusters are in the halo of the Milky Way galaxy, they don't pass through the spiral arms. They don't pass through all those clouds of gas and dust that would form new stars. So these stars are just the old original stars that formed in this cluster.
And this is one of the more outlying globulars in the galaxy at about 58,000 light years away.
Hey, Gerald, guess who discovered this?
Oh, our good friend.
How do you pronounce that name?
Bode. Johann Bode. Now, one of the interesting things, we were talking a while ago about how old stars or stars that blow up in a supernova, they scatter all these heavier elements around, and then the gas and dust from those supernova explosions combines with other gas and dust and forms new stars. And those newer stars have more of those heavier elements than the previous generation of stars. Astronomers consider anything heavier than helium to be a metal. Makes no sense, but that's what they call it. And so when we find stars that have a lot of those heavier elements, we say they are higher in metallicity. And the thing about globular cluster stars is they're among those first generation stars. So they are very low in terms of metallicity. These stars are mostly hydrogen and helium, and not a lot of the other heavier elements that would have come from multiple generations of supernovae and dying stars that would have sort of polluted the region with all these heavier elements. All right.
Well, at one point, this was thought to be the most metal poor globular cluster in the galaxy. I guess another one superseded, but that's where it was.
Okay. All right. What's next on our list? This is what, M50? M64. Oh, we've got some good images of M64.
This is a good one, yes.
Yeah.
Yeah, it is.
M64 is called the Black Eye. galaxy, and you'll see in a second why we call it that. And I'm actually going to share two images. So this, I actually got to bring it up here. This is the Hubble Space Telescope image of the Black Eye Galaxy. And you might look at this and say, well, why do they call it a Black Eye Galaxy? You see this very dark region here. This is very dense clouds of gas and dust within the spiral arms of this galaxy. Again, this is a Hubble Space Telescope image. It's sort of zoomed in. It doesn't show the full extent of the galaxy. But I've got another image here. Maybe you guys can talk a little bit while I dig it up.
I'm sitting there trying to dig up images of this too, because I remember the one that we did, which showed the jet.
Right.
Was
I
this
have
is
it.
also called the Sleeping
Not
Beauty
the jet, I meant
Galaxy.
Yeah. Okay. So
Yeah.
so we've stalled enough. I've actually found the other image.
Okay, good.
Oh, you did.
That didn't
Good.
take
Okay.
long.
Okay. So
Yeah.
here
Good
is
thing. Yeah.
yeah. This is the same galaxy, the Black Eye Galaxy,
Yeah, there we
Messier
go.
64. This was taken with our telescope right here behind us about, gosh, what, 6 months ago? It's been a while
Yeah,
since
yeah,
we
yeah.
did this. So,
Yeah.
so you can see this dark region that was kind of close up in that other image. This is why it's called the Black Eye Galaxy. All right. So this is Messier 64. And
I
Messier,
remember this. I think I processed
Yeah.
this.
Yes, you did. We took a bunch
Yeah.
of images with my astronomical CCD camera, and
That's
then
right.
you processed them. It's about 19 million light years away in the constellation Coma Berenices, Berenices Hare.
Nice.
All right. Okay. So our next object, I believe, is M3. Yes, M3.
Indeed.
So try to find it's
Oh,
another
M3.
globular star cluster in Canis Venatici, although it often to me seems to be close to Botis, but we'll just go with what they say.
I got to share a ridiculous story about M3.
Okay.
All right.
All right.
So
Okay.
I
Make
was
sure
out.
it's
It's rated G. It's okay. I was out at the Elval Reservoir with a couple of members of the Tri-Valley astronomers, and including one EAS member at the time, and we were a little bit shaken up because at one point a whole herd of cows surrounded our telescope, and they were in a circle around us, all facing in towards us. And we had these three telescopes and this circle of cows around us. And then one of them got kind of interested in our license plates and started licking the license plates because there was some salt on the road or something like that. So they got interested in that. So we were a little bit, like amazed at that whole scene. And then we're looking through our telescopes and we thought we had discovered a comet. But in fact, we had discovered M3.
Rediscovered.
So we were kind of channeling Charles Messier that
yeah,
night.
really.
And, the whole night was ridiculous. But anyway, it just goes to show you, it's easy to confuse these things with comets.
Cows must have been astronomers. They must have
Yeah.
been interested in the stars.
It was a weird night. It was a very weird night.
For those of you who joined us late, the reason Charles Messier made this list of all these different fuzzy objects in the sky is he was hunting for comets. And the way he would find comets is he would scan the skies with his telescope. This was 200 plus years ago. And he would look for faint fuzzy objects, and then he would watch them over a period of, sometimes a couple of days to see if they moved relative to the background stars. Comets would be faint and fuzzy, and they would move relative to the background stars. Well, he would encounter quite often faint fuzzy objects that didn't move. So rather than rediscovering those same faint fuzzy objects over and over again, he made a list of them. And that's what we call the Messier Catalog today. All right. So this is M3. It's got about 500,000 stars in it. And as
Yeah.
before, the stars are orbiting around the center. They are in highly elliptical orbits. And then, of course, the cluster itself is orbiting around our galaxy in what we call the halo of our galaxy. All right.
Now, there is something unusual about this. Aside from it being a really beautiful globular cluster, probably considered one of the most spectacular next to M13, it has a very unusually large number of variable stars in it.
Right.
And that's why it's very heavily studied.
And it's almost 40 million light years or 40,000 light years away. So it's one of the more distant ones. Okay, let's see. Our next object is Messier 98.
98.
All
A lot
right.
more stars in this one. This is another
Oh,
galaxy.
Yeah. And this one again is in Coma Berenices.
Oh, yeah.
And I do not have an image of it. So
I got one here.
Okay. All right.
Let me see. It's not the best image in the world, but
It's a
it
galaxy
is
about
a image. Let me see if I could get my
It's about 60 million light years away.
Yeah.
sorry here. Having problems bringing up my zoom.
This
window.
is,
Here
as
we
you'll
go.
see, an edge-on view.
There we go.
There it is.
It's actually kind of neat. It's got this like double level effect where you see this spiral down below and one kind of above. It's like it's been twisted. Anyway.
Almost helical.
Right. Yeah.
Helical. That's the word I was looking for. Thank you.
Okay, our next object is Messier 99, which is also in Coma Berenices. It's about 60 million light years away. It's another spiral galaxy, and once again, I don't have an image of it. So,
all right, I've got one here.
Okay.
This is another one about 60 million light years away.
And it's part of a large group of galaxies that are in Coma Berenices. So,
yeah.
This was taken with the Mount Lemmon telescope in
oh,
Arizona.
really?
Yep.
Why were they taking pictures of this instead of asteroids?
You're gonna send in your complaint?
That's right. That's right. Mount Lemmon is supposed to be doing nothing but asteroid hunting. All right. And again, this object is 60 million light years away in Coma Berenices.
It's considered part of the Virgo cluster of galaxies.
Yep.
Even though it's in Coma Berenices.
And the next object, again, is in Coma Berenices and is another spiral galaxy called Messier 100. And again, I don't have an image of it. So,
all right, I will show you the one I've got. And there we go. M100. There we go.
All right.
I've got an interesting. I'm going to share this one too because it's a
go for it.
Variation on what you have.
Sure.
But a different color.
Oh, yeah. A galaxy of a different color. Okay. All right. The next object is M85, also in Coma Berenices, also about 60 million light years away. It's a lenticular galaxy. And again, I don't have an image of it.
All right. I will share mine.
We got here.
There we go.
And again, discovered by our friend Pierre.
And this is a Hubble Space Telescope image.
Oh, really?
Yeah.
All right.
And these elliptical galaxies are really odd to look at. They just are. They're kind of subtle through an amateur telescope. You see kind of a a light glow, an oval glow. The Hubble obviously is a much more sensitive instrument and is able to pick out the contrast of the core from the rest of the galaxy, because the galaxy here actually fills the entire field of this image, but the core is exceptionally bright, and the ability of the Hubble to pick out the contrast is pretty amazing.
Is that because of higher density of stars?
I guess,
Or
yeah, it would have to be, right?
Yeah, I guess.
All right. Well, our next object, speaking of the Virgo cluster, is in the constellation Virgo. It's another lenticular galaxy called Messier 84. Again, about 60 million light years away. And again, I don't have an image of it.
All right. Yeah, you're kind of starved for images all of a sudden over there.
Well,
I have an image, but it looks like it's more than just that.
M84 is kind of interesting looking. Hold on, let me show you this image that I picked up here. Whoops, you've got it. Yeah, it doesn't show that feature that I've got. Let me show mine if you don't mind.
Okay, sure.
There we go. This is the Hubble image. And you see these interesting clouds.
Yeah.
So there you go. And you can see that it's another elliptical galaxy, and the galaxy itself is really, you could see my cursor going around. It's really filling this entire area. A lot of contrast between the core and the outer parts, and then these clouds obscuring the core somewhat, which are really interesting. I don't think I've seen that anywhere on any other.
Yeah, you're calling it an elliptical, but it's also considered to be lenticular.
Oh,
lenticular is sort of in between spiral and elliptical.
And elliptical. So that's interesting.
So
that may be, and it may be considered lenticular partly because of these clouds still being present. I don't know. Here, you guys can see the spiral arms a little bit, maybe.
Well, in the same region, again in the constellation Virgo, and again 60 million light years away, another lenticular galaxy called Messier 86. And again, I don't have an image of it. So,
all right, I'll get that here. Oh, you got my share? You see that? Yeah, you got it. Yeah, it's really hard to tell the difference between an elliptical and a lenticular sometimes. I don't see the remnants of the spiral arms so much in this image, so it's curious to me that it would be classified that way.
All right, and continuing on, yet another object in the same cluster of galaxies. This one truly is an elliptical galaxy. It is called M87. Also 60 million light years away, and I hope you got an image because I don't.
Oh yeah, let me get one here. I was getting ready for you to. Oh well, this is what we were talking about earlier, was the jet that is visible in M87, and you can see in this Hubble image. I believe it's a Hubble image. Maybe yes, maybe no. You could see the blue jet.
Oh yeah,
coming out of the core of that galaxy. Do you happen to have the one that we took in your?
I might have
there?
it somewhere.
Yeah, I could not find it. I know I have it on like Facebook or something, but I don't have it on my hard drive.
Yeah, we worked quite a bit at that, as I recall.
Yeah, we did. Yeah, I don't know if we have it.
Yeah, I might have to look around here.
This is a really good image. This one is one of the most spectacular pictures of the jet that I've ever seen. So, no complaints.
Yeah, I don't find it off the top here. It's probably buried in my computer somewhere. You know how that goes. So the next object, staying with the Virgo cluster, is another elliptical galaxy, M89. Once again, about 60 million light years away. And again, I don't have an image of
Okay.
it.
Stand by. I'll get one up. Oh, interesting. All right. This one has a nearby neighbor. So M89 is the elliptical here, right? And then I'm not sure what this little guy is here.
That might be M90 because that's the next object
Ah,
on our list here.
Now, a lot of these are all very close together in the Virgo
Right,
cluster.
right.
Okay.
Actually, it's not M90, but anyway, the next object is M90. But I should also point out we're halfway through. So 110
Yeah.
objects. We are on number 56 right now. So we're a little over halfway through. So M90 is our next object. It's another spiral galaxy in the Virgo cluster. It's 60 million light years away. And another one where I need your help as far as images is concerned here.
There you go.
Okay, that's actually a pretty good image.
Yeah, that one is.
Yeah. Is that a Hubble?
I think it is. Yeah, HST.
Okay.
If you look at the image title in the URL.
Okay. Well, our next one is also in Coma Berenices. It is another spiral galaxy called M91.
Oh, that's nice. You need a image?
Actually, I have one here.
Yeah,
Hang
go
on,
for
it. It's a pretty nice image.
Yeah, go for it. You've made my arm tired.
Is that a spiral arm?
Yeah. Now it is.
Yeah. So here we have another spiral galaxy. This is in Coma Berenices, part of the Virgo cluster. And it's about 60 million light years away again. Now, I'm not sure if this is a true color image or a Hubble palette image. I suspect it's a Hubble palette image. There's an awful lot of blue in this image.
Yeah, there is, isn't there? Yeah.
Yeah. So M91, right? And continuing on here, back into the Virgo constellation, M58. Here we go. All of these are listed as having roughly the same distance, about 60 million light years. But I think that's just kind of a rough round number here. So I've got an image of it. And it's a partial image because, again, it's so big it fills the field of view of the telescope. So they had to mosaic it. And here it is. Nice clear view of all these star-forming clouds. And you can just see the evidence of star-forming regions in these dark bands here.
Very detailed image. That's really nice for something that's that far away.
All right. So nearby is M59, which is another elliptical galaxy, and I don't believe I have an image of that.
Well, here you go.
Oh, no, I'm sorry. I do have an image.
Too late.
But my image is only a small portion of it, so yours is much better. Okay, mine only shows about half of that, so yours is better. So this is M59, again, 60 million light years away, part of the Virgo cluster. And is it elliptical? I guess it's an elliptical galaxy.
It looks like an elliptical. But
yes,
if we look closely, they'll probably end up classifying it as a lenticular.
No, it's actually classified as an elliptical.
All right.
And sticking with our Virgo cluster, we have next is M60. Again, part of the same cluster, 60 million light years away.
Elliptical.
And I do have an image. And it's an interesting image because it has an extra object in it. Let me share that.
Yeah, mine has that image as well.
Yeah, so here it is. This
Yeah,
is
that's
M6.
cool.
Okay. This object here, which for some reason I guess Hubble couldn't see. I mean, Messier couldn't see. I'm not sure what the story is here, but that is actually a. Hang on here, just a second. I think I've got some information about it. It's a separate spiral galaxy in the background. It has an NGC number. It's not a Messier object. It has an NGC number. I think it's 4746 or something like that.
That looks like a. I'd love to do a photograph of that.
Yeah,
That's a great pair.
yeah. Okay. So our next object here, I'm lost. Oh, there we are. M49. I think there's something odd about M49 as I remember. M49
It's another
again.
giant elliptical.
Elliptical galaxy. Yeah, let me
Do you have
stop
a
my
picture?
thing. Yeah, hang on here. I don't know if I do or not.
I have a kind of a crummy one. I have a crummy Hubble image. It's actually one of the worst Hubble images I've seen.
I didn't think there was such a thing.
Yeah, this one is not a particularly good Hubble image.
Yeah, it looks like I don't have one.
Where are we? I lost track here. Are we
M49.
M49.
49. Okay.
There we are.
Okay, so an elliptical galaxy, again, part of the Virgo cluster, 60 million light years away. All right, moving on. M61, yeah, M61. I got to move this down here so we can do that a little bit better.
I'll bet you have a photo of that.
M61. Come on, thank you. All right, let's see if I have a photo. Yes, I do.
There's some interesting trivia about this one. So it was first discovered by Barnaba Oriani on May 5th, 1779, 6 days before Charles Messier discovered the same galaxy. But Messier had observed it on the same night as Oriani, but mistaken it for a comet.
Yeah. He just wanted to see a comet so bad.
I wonder if they were surrounded by cows.
Okay, so again, 60 million light years away, part of the Virgo cluster. All right. Okay, so what's next on our list?
104. Oh, this is a good one.
104.
M104, the sombrero. Yeah, sombrero. And I definitely
this is one of our favorites.
I definitely have.
Also in Virgo, a little closer at 50 million light years.
All right, and hang on, let me pull up the image here. Get down here into the hundreds.
Also discovered by our friend Pierre.
Oh. And here we go. There it is, the Sombrero Galaxy.
It's a very dramatic looking galaxy.
Yeah. One of the interesting things about it is it's hard to see, but you'll see little faint, fuzzy little objects here and here. These are actually globular star clusters. A group of astronomers went through the exercise of identifying and mapping all of the globular star clusters that were orbiting around this galaxy. I think there's over 200 of them that they were able to map. Pretty interesting. I've got an image somewhere showing where they've actually, put little boxes around each of the globular star clusters. Not going to try to find it now, but This is another almost edge-on spiral galaxy. It has sort of an elliptical appearance to it, and that's because it has a very massive black hole at the center. This is
Yeah.
one of the most massive black holes
It's a
in
big
spiral
radio. It's
galaxy.
a big radio source, and it also is a big source of synchrotron radiation, X-rays, and very powerful magnetic fields.
Richard, we have a request that you show where the Virgo cluster is on your star map.
Oh
Yeah, we haven't been doing that, have we?
We really haven't been. I've been
Virgo cluster
remiss.
is sort of, from the northern hemisphere, it appears in the southern part of the sky, so it's kind of low, and it's definitely a summertime object.
So if I use as an example, like what was the last one we looked at? I don't want to use 104. Let me look at like M61 or M60.
Okay.
That would be a good one.
Yeah, M61 was the previous one.
Yeah. So that's fine. And let me share my screen.
Point out in general where Leo is and or Virgo is rather.
Hold on. Sorry, folks. I gotta switch computers. Okay, there we go. So here's Virgo. And here's Coma Berenice's hair. And here is Leo. Remember Leo, the backwards question mark? And Corvus, the crow, over here. And these are tough constellations to pick out from the city, I think. But just to give you some orientation, here's Ursa Major, the Big Dipper, right?
Tail end of Leo kind of points right into it.
Yeah, it does. And that's a good way to do it. So if you see the question mark and you follow Leo over to the arrow here, then this whole area is where you're finding all of these Virgo cluster objects.
Right.
All right.
So Richard, while you got the map up, kind of point out Hydra over there on the right.
Yeah, I have to move your picture out of the way here. Hold on for a moment, Gerald. Don't be offended.
Just move your laser pointer over a little bit.
Yeah. Here's Hydra.
There you go. Yep. So that is the longest constellation in the night sky.
It's just as long. It's the dragon, right? It's this long.
Is it a dragon or a sea serpent?
Or a serpent.
It's a serpent. It's actually a snake. It's part of the tail of Apollo and the Corvus the crow and Crater the cup and Hydra the snake. That's kind of a little story that goes all around that involving Apollo. But the reason I wanted to point out Hydra as our next object is in Hydra. It's a globular star cluster called M68. And if I can
stop
bump
my share,
off there.
Please do.
And
that's funny. Margot said, "Where are the agents of S.H.I.E.L.D.?" I was just thinking that. We're talking about Hydra. That's funny.
Okay. So this is M68, a globular star cluster, another one of these balls of stars out in space. It has probably close to 1 million stars in it. It's 33,000 light years away, maybe a little bit more than that, maybe 33,300 or so. It's about 106 light years across. And just to kind of put things in perspective with these globular star clusters, if you look around the sun, where all the stars are, if you go out, say, 10 light years in any direction, and imagine a sphere around the sun that's say 10 or 15 light years across, there's only maybe half a dozen stars in that sphere. But here you have a sphere that's 106 light years across, and it has nearly 1 million stars in it. So that just gives you a sense of how close together these stars are. And as I said before, if you lived on a planet orbiting one of these stars, you wouldn't have a nighttime because there'd be so many stars in the sky all around you.
It's so bright because
Yeah,
they're so close.
I can't remember, was it Isaac Asimov or Arthur C. Clarke who wrote the Nightfall book?
Oh, Nightfall was
I think it was
Clark.
One
I
of those
think.
two, I think. Yeah.
Yeah.
I have to look
Yeah.
now.
Yeah, so he wrote a book about a fictitious civilization living on a planet orbiting a star in a globular star cluster.
Asimov.
Asimov. That's
Okay.
what I thought. Yeah. And he wrote this fictitious story about a civilization on a planet orbiting a star in a globular star cluster. And most of the time, they never had a true nighttime. But once every, I think it was 100 years or something like that, everything would line up just right, and they would have a true dark night. And
I
it
don't know
was
how he
such,
came up with that concept, but
and it was
it's pretty interesting.
such an interesting event, unusual event that the whole planet had kind of a celebration when you had one true dark night every 100 years. So anyway, this is M68, the globular star cluster M68, which is in the constellation Hydra. All right. So
All
our
right,
next object is M83, also in Hydra. Yeah, M83. Let's see what we can find about
Closer
M.
galaxy, 15 billion light years.
It's another object called a pinwheel galaxy, but this is the southern pinwheel galaxy, and it is M83. And yes, I do have an image. And let me just share that image with you.
It was actually discovered at the Cape of Good Hope by Louis de Lasalle.
Yeah. I was going to try to pronounce that, but I decided
I think it's
not to try.
I don't know if it's Lacaille or Lasalle. Yeah, I'll do my best here.
If it's Lasalle, then the C has to have a little hook at the bottom of it. So,
yeah. Oh, okay. There. Fine.
Yeah,
I think you're right. Yeah.
Okay, so this is again M83. It's in the constellation Hydra. That really long one that we were pointing out. It's
that's nice.
15 million light years away, and it's another spiral galaxy. And again, you can see the two arms coming off the central bulge. But again, we see some spurs coming out of these arms at different places here. All right.
We've observed 6 supernovae in M83
Oh,
since we started looking.
Above the average?
That's above average, yeah. Typically, you only get one supernova every 100 years or so in any given galaxy. So the fact that you've had 6 of them in, 150 years, that's kind of interesting.
Good rate.
All right. We have another globular star cluster coming up, M5. All right. So,
yeah, I'm my internet's. Here we go. I'm back.
Okay, yet another globular star cluster. This one is a really dense one. All right. And this one is about almost 25,000 light years away. And it is in the constellation Serpens, which is a kind of a funny constellation. It's actually in 2 halves, Serpens Caput and Serpens Cauda. And they're on either side of the constellation Ophiuchus. So this is M5, which I believe is on the kind of the eastern side of Ophiuchus, southeastern side of Ophiuchus. And it's a globular star cluster. Like I say, it's about almost 25 million or 25,000 light years away. And you just see how dense it is. Now, when you look at these stars, most of the stars are either white or yellowish, but you might notice that there's a few blue ones in there. Because these stars are so close together, they sometimes bump into each other or get so close to each other that one star will pull matter off of the other star. When that happens, you either get a merger of two stars, which suddenly takes two relatively cool low mass stars and makes one much hotter, higher mass star, which makes it show in the blue color, or you strip away the outer layers of a lower mass star, exposing the hotter core, which then shows in this bluish color. So we call them blue stragglers. We didn't expect to see those in globular star clusters, but they're there, and it took a while to figure out why they would be there. And that's the story. It's just because so many stars are so close together, you just get those either mergers or getting material stripped off of a star.
We have a couple questions here about how late we're going
Oh,
tonight. Since we're starting to
well,
go beyond our normal time, probably
yeah.
ought to.
Let's see. I actually didn't
look
share
at
that, did I? There it is. All right.
Probably.
Yeah.
We,
Our
we,
original plan was to go all night.
we also got a kind of a maybe a trick question here. What galaxy doesn't have a black hole at the center of it? I don't know if we know of one, do we?
Yeah, I'm not sure we know of any. Okay, so we looked at M5, which is a very dramatic globular star cluster. We have yet another globular star cluster, probably the most famous one, M13. M13 is in the constellation Hercules, and it's one of the easiest globular star clusters to find because of Hercules' unusual appearance. It's very easy to spot in what we call the keystone of Hercules. There's a pattern of four stars that forms kind of a trapezoid shape. We call that pattern the keystone. It's what we call an asterism. And M13 lies along one side of the keystone. It's very easy to spot. And if you're in a truly dark sky and you've got really sharp eyes, you might even be able to see this object with your naked eye, and definitely pick it out with a pair of binoculars. It's about 25,000 light years away, and it has well over 500,000 stars in it. And again, the stars orbit around the center of the cluster, and the cluster orbits around the galaxy in the halo. All right. So this is M13. Okay, our next object, also a globular star cluster and also in Hercules, is M92. Yeah. So M92, I believe I have an image of what was. Did I share that image of M13? Probably not.
I did notice.
Yeah,
But
I think it's this one. Is this it? Yes, that's M13. And so let's share now M92.
Another one discovered by Bode.
Do you want me to show a map of where Hercules is?
Yeah, that might be a good idea.
Yeah, because
this one's one that people can easily find with a pair of binoculars. Yeah,
that's right. And so Hercules is just starting to rise right now. It's you're looking to the east here where my arrow cursor is and where you see the laser pointer pointing, and it's pointing right now to M13. So what you see in the sky, at least in the summer sky, is really the time to be looking at Hercules, because it'll be much higher in the sky in the summer months at a reasonable hour. As you look for this, it's not a square, it's a little bit more of a trapezoid. And this trapezoid shape should not be confused with the one in Draco, which is much tinier. I used to confuse those two, and then as I got more experienced, I realized which was which. And if you look on the west side of M13 and look for the two bright stars here and here, and go about midway, but a little bit closer to this one here, then you'll see M13. Now, you probably won't see it naked eye unless you're in a really, really dark spot, but you'll easily see it with a pair of binoculars or a small telescope.
Okay. Our
And
next object, although I don't have an image of it, it would look very similar, and that's M92, which is also in Hercules. In fact, if you go
let me
back to
see if
that
I could
image,
bring that up. Yeah. Let me see if I can get M92 here for you. Yep. All right. I'll share that. There you go.
okay, looks like a Hubble image.
Yep.
Yep, so this is M92, another globular star cluster, and it's also in the constellation Hercules. It's outside of the trapezium, sort of north of the trapezium. I'm sorry, not the trapezium, the keystone.
Keystone. Sorry.
Yeah,
Yeah.
yeah. It's four stars in a trapezoid pattern. You know?
I just tried. I'm rubbing. I'm starting to rub off on you, Gerald.
Yeah, right. Okay, so that is M92. Our next object is another really spectacular image or object frequently photographed. It's M57, the Ring Nebula.
Oh yeah.
And I'm going to go ahead and share
Frequently
an image.
observed up here when we're
Yeah.
open.
This is a Hubble Space Telescope image. I have several images of this taken with our own telescope here at Chabot. But this is another planetary nebula. And again, a planetary nebula is the remnant of a dying star. It's a star that shed its outer layers of gas. Whatever's left of the star has collapsed into what's called a white dwarf. We can actually see the white dwarf. It's right here at the center, and it is surrounded by all this gas that was expelled in several episodes prior to it becoming a white dwarf. White dwarf now is emitting ultraviolet radiation, which goes out and it ionizes the gas in the cloud, causing it to glow. Now, you see kind of two dominant colors here, kind of reddish orange here, and then kind of a bluish green color here. And those colors tell us a little bit about the composition of that cloud. Now, the outer part of the cloud is reddish orange. That's because it's mostly hydrogen. The inner part of this cloud is also mostly hydrogen, but it has a fair amount of oxygen in the cloud as well. That tells us that this star, when it was reaching the end of its life, it got to the point where it was actually fusing carbon to make oxygen. And oxygen has a unique characteristic. When it's ionized out in space, it will glow in a kind of a bluish green color, turquoise color. And it's unique because it only happens in space. We can't reproduce this in the laboratory here on Earth. And it's because you try to do it in a laboratory on Earth, and those ionized oxygen atoms too quickly capture electrons and become less ionized. But out in space, because it's so diffuse, it's basically a vacuum, these ionized oxygen atoms can remain ionized long enough for them to glow the way you see it here. So when astronomers first were observing objects like this and were seeing this color, they didn't know what was going on because there was nothing that they could see in the laboratory that produced this kind of bluish green glow that you see. And so they actually gave a name. They thought it was some new gas or new element that they didn't know about. And so they called it nebulium because this is a
Yeah.
nebula, right? So it was a gas in a nebula. They called it nebulium. Well, eventually they figured out that it was actually just this unusually ionized oxygen. So this is the Ring Nebula. It's one of the easiest things to find, again, because its position relative to the other stars in the constellation Lyra, and it's frequently photographed by amateur astronomers. It's one of the easier things to photograph.
Well, while we're at it, let me show people where this is,
Uh,
because this is another one you want to look for.
Easy
And
star hop from
yeah,
a
it
very
is.
bright star, Vega.
So I had to advance the clock on my planetarium program. If we were doing this live with Nellie tonight, it would be 3:30 in the morning. All right. So I just want to say that we are engaging in some time dilation by doing this virtually. So here's Hercules. And remember, we talked about M13 being midway between the two Western stars in Hercules. And if you go a little bit to the east from Hercules, you'll see a very, very bright star, Vega. And in Vega is just alongside a parallelogram called Lyra. And at the far end of that parallelogram, if you go right midway between the two stars, exactly halfway, you'll see the Ring Nebula. And in fact, let me magnify this a little bit and drag it over. Come on, don't do that to me. Hold on. That's not working. Here we go. No. Let me look east. There we go. That's what I meant.
Says, what are you trying to do? This object is below the horizon right now.
Yeah, here we go. So it's right in between the two stars on the far side of the parallelogram from
in the
Vega.
constellation Lyra.
In the constellation Lyra. Yes.
Now, M57 is so spectacular. It looks so beautiful in a telescope that whenever anybody's pointing a telescope towards Lyra, that's what they like to look at. But there's actually another object, another Messier object in the constellation Lyra. It's another one of these globular star clusters called M56. And M56 is about 33,000 light years away. And I'm going to share an image of it. And there it is. Looks just like a globular star cluster. So these we keep showing you globular star clusters, and you're probably thinking, "Gosh, they all look alike," and you'd be right.
They do. Yes.
Well, they are classified the same. So
Yep.
That's why.
So that's M56. And let's see, our next object is in the constellation Cygnus, the Swan.
Yes.
M29.
Back to open clusters.
Yeah. All right. And I
Another
don't
one
know.
discovered by Charles Messier himself.
Do you have a picture of that one, Gerald, or no?
Hang on a second here.
I have a nice one if you don't.
Right. I have one.
Okay. Yeah. Go ahead. So M29 is an open star cluster about 4,000 light years away. It kind of looks like the Pleiades, doesn't it?
It does. I was just thinking that.
And again, these are stars that all form from a cloud of gas and dust at about the same time, and they're all about the same distance away. And they are drifting together through space, slowly drifting apart from each other. And this is how stars form. All right. Okay, M29. Next object is M39, where is M39? M39 is also in Cygnus.
Cygnus. Yep.
Yeah, it's another open star cluster, and I'm not sure if I have an image of it or not.
Here, I'll grab one. There you go.
It's kind of sparse.
Yeah, I don't have an image of it. So
this is a particularly unexciting open
right.
cluster. Yeah, but I mean, it is notable because of the uniformity of the stars and their color. That
Written
is,
up as
I mean,
a,
they're
a
all,
very large but
yeah,
very loose open cluster.
yeah.
Boy, that's almost imperceptible as a star cluster, isn't it? Yeah. So that's
Well, it's in a very crowded part of the sky. I mean, it's right there in the very close
Yeah.
to the Milky Way in
yeah,
Cygnus, and
it's kind of far away. It's 825 light years away. Okay.
Yep.
Our next object is M27.
I knew that was coming.
Another planetary.
Yeah.
Yep, another planetary called the Dumbbell Nebula. All right, and
You probably have one. Yeah.
I do have a Dumbbell Nebula image, and this was actually taken with this telescope here at Chabot.
Oh, great.
All right, so there it is. The Dumbbell Nebula. It's another planetary nebula, another remnant of a dying star. Again, we have a white dwarf at its center, surrounded by all this gas, which has that bluish green color, which tells you it's what? Oxygen, right? Ionized oxygen.
Weird
right?
oxygen.
And then you see a little bit of reddish orange here. That's the hydrogen. And it's called the Dumbbell Nebula. It's not so obvious here, but there's kind of a dumbbell shape to it, hence the name Dumbbell Nebula.
Yeah, it's not a commentary on the astronomers who discovered
this is yeah, right. So this is about 1,250 light years away. All right. So let's see. What's our next object?
M71.
M71. Okay, that's a good one. Hang on just a second here while I do a little adjusting.
That's another open cluster, I believe.
It's a globular, actually.
Oh, is it?
Yeah.
Oh,
Yeah,
it's globular. Look at that.
Another globular. Yep.
My
Now,
bad.
let's see. Do I have an image of it?
I have one here from the Hubble if you want.
Yep, I've got one.
Oh, you do? Good. Let's see what yours
So
looks like.
mine probably looks very similar because it's also from the Hubble. so
Maybe
there
the
it
same
is.
image.
So this is a globular, huh? Boy, it's not a very dense one, is it?
No.
Yeah. Yeah. This one is 13,000 light years away, but it's kind of diffuse. Yeah. Interesting. So again, globular star clusters orbit the galaxy in the halo of the galaxy, so they're outside of the spiral arms. And the stars are very old stars.
Yeah, in fact, the classification was uncertain for a long time. Many astronomers thought it was a rather condensed open cluster, similar to M11.
All right.
But
So,
not so.
Our next object is M107, right?
No, I was really okay.
Yes.
Your list is different than mine. All right, go for it.
Yeah, okay. Yeah, mine shows M107 as the next object.
I'll go with yours.
Backholtz's list, right? I'm using this German
Well,
guy.
it could be my own for all I know.
Okay. So M107.
I don't know who did this list.
Yeah, M107 is yet another globular star cluster.
In Ophiuchus?
In Ophiuchus, I do not have an image of it though, but it probably looks like a globular star cluster.
Sure
Yeah,
does.
you won't believe what this one looks like. Here, hold on.
It looks like a big ball of stars.
Looks like the same as the other one.
Yeah, there you go. All right.
This one's a little less symmetrical than some of the other ones.
And this one's almost 21,000 light years away.
Well, that's reasonable. That's relatively close for a globular cluster.
Yep. Okay. So moving on here. M12 is yet another globular star cluster, also in Ophiuchus. And let's see, do I have an image of it? Yes, I do.
Looks a lot like the other ones.
and it looks just like all the others. There it is.
Notice that this one's a little more symmetrical than the other one, a little more.
Yeah, yeah.
But it's got. Are those red stars part of the cluster, or are they foreground?
I think they're part of the cluster. So, but don't quote me on that.
Right.
And this one's relatively close. It's only 16,000 light years away. So,
And SED says that this is nearly a twin of its apparent neighbor M10, which is the next one that we're going to look at.
Yeah, that's the next object, right? Yeah. And both of these are in Ophiuchus, the constellation Ophiuchus, the healer. Whole little story about Ophiuchus and snakes. So M10, yes, I do. All right. And by golly, if it doesn't look just
like its neighbor,
look just like another globular star cluster. There it is. And this one is even closer, 14,300 light years away. Now, you'll notice some of these globular star clusters look a lot denser in the center than others. Some seem they're pretty dispersed, but others look like they're very dense in the center. And the dense ones at the center are what we call core collapse globular star clusters. They have most likely have black holes at the center of the cluster, and the stars are no longer spinning way out, doing those long trips out to the core. They're much shorter orbits, so they stay in closer and tighter, and so we call that a core collapse globular star cluster. All right.
Well, the next one is another globular star cluster, but it's a really neat one, M14, right?
Imagine that. Yeah.
Also in Ophiuchus.
I'll tell you, my internet keeps cutting out, guys.
I've noticed that a couple times.
Yeah, mine is out right now, but it'll come back. But it's
just kick the computer.
Well, it's the Wi-Fi.
You just went out again.
Just died. Okay, so in this case, this one is actually pretty far away, but Hubble, for whatever reason, couldn't get an image of the whole thing, so they only got a partial image here where they've tiled together.
Is this M14?
This is M14. Yeah,
I've got a much better picture of that.
Then let's share your picture.
Let me share mine.
All right. Assuming your internet holds together.
A good black and white image.
Well, if my internet goes, it'll be the last thing you see. Yeah, this one's got a lot of symmetry to it. It's really pretty neat.
Oh yeah.
30,000 light years away.
Yep.
And 72 light years across, and the total luminosity, it's about 400. What did it say? 400 or 400,000 times the luminosity of the sun.
Oh.
Overall.
Okay. There's a lot of stars there.
Yeah.
There are.
And keep in mind, those stars are mostly lower mass stars than our sun. So the stars are not as hot as our sun would be. If they're still main sequence stars, which they likely are, they're not as hot as our sun. So that tells you there's a lot of stars in this cluster. All right. Let's see. Next object is M9. And yes, I do have an image.
Another one of those globular clusters in Ophiuchus.
Yep.
This one about
there you go. Another
almost 26,000 light years away.
Yep. And what can we say that we haven't already said about globular star clusters?
Right? There's a lot of them.
Yeah. The only thing about this one is it's right on top of a dark cloud of dust designated Barnard 64. Barnard objects are the negative space of astronomical catalogs. It's always these dark dust lane, absence of light objects that Barnard cataloged, and this particular globular cluster sits right on top of one.
Okay. Speaking of globular star clusters, we have yet another one, Messier 4, which is another
Oh yeah.
globular star cluster in Scorpius. Scorpius is down low in the southern sky for those of us who live in the northern hemisphere. Uh, what did I just do? Where am I here?
Do you have a picture?
I do, if I can
Okay.
get myself oriented here.
This is another one that's very easy to find, and I'll
Oh,
just bring up my
this
map
this
after you're
is
done showing the picture.
this is another Hubble Space Telescope image, and there it is. A little bit more diffuse. It's only 7,200 light years away, so it's pretty close, and it's in the constellation Scorpius. Um,
That's very close for a globular star cluster.
yeah,
Isn't it?
yeah. And now Scorpius is on the night sky. It's very close to the central bulge of our galaxy. So this thing must be pretty low in the sky and pretty close to the disk. So it's, globular star clusters are normally out in the halo. So this one must be fairly low to be in Scorpius. So.
Let me show you where that is. It's very easy to find with binoculars. And so Scorpius is another constellation that you want to be looking at in the summertime. And its most notable feature is this this string of stars here and the string of stars here. It almost looks like a T in the sky. And there is a bright red star in Scorpius called Antares. And Antares, it actually means against Mars. And it has a very similar color to Mars and a very similar brightness to Mars. And so it was named, in a sense, after Mars. But M4 is just alongside Antares. So you just move your binoculars a little bit to the right and you'll see it.
Now, some people say Antares doesn't mean against Mars, that it means not Mars. And because it's similar in appearance to Mars,
and it's near the ecliptic, so Mars actually goes by it.
Yeah, Mars sometimes actually gets pretty close to it. So, one object is Mars and the other is not Mars or Antares. All right. So our next object is M80.
It's
M80.
Not a firecracker. It's actually
yeah, I searched for that, and now I'm coming up with explosives.
You've got to stop doing that. All right, so here is M80, nice dense core collapse type globular star cluster. All right, and it's in the constellation Scorpius again. It's almost 33,000 light years away. So likely it's actually beyond the central bulge. So we're looking just over the top of the central bulge off into the other side, if you will, of the galaxy.
This is another one discovered by Charles Messier himself.
Oh, all right. And probably he tracked it for a while before he realized it was not a comet.
Not a comet. There's an anti-comet? Is that what?
Right. Okay, so that's M80. Next object is M19. M19. So what is M19? M19 is another globular star cluster in Ophiuchus. And do I have an image of it? I'm not sure.
I got one here. There you go.
Okay. Yours is probably the same as mine. Yep, it is. So M19, another globular star cluster. Dense core, so that means it's probably a core collapse globular star cluster.
Yeah.
This one is 28,000 light years away. And again, it's in the constellation Ophiuchus. Ophiuchus, the healer, or the medicine man sometimes. All
Now,
right.
wasn't Ophiuchus originally going to be part of the zodiac, and then it was dropped?
Well,
Is that Ophiuchus?
it's sometimes
Yeah,
considered to be the 13th
13th.
constellation on the zodiac,
Zodiac.
because the ecliptic runs through one little corner of Ophiuchus.
I
Yeah,
see.
right,
So,
right by his feet.
so there's a whole story about Ophiuchus, how he was wandering through the woods and he saw a snake, and his instinct was to kill the snake right away, and he did that. And then along came another snake with some herbs and gave the herbs to the dead snake and brought it back to life. Is it herbs or herbs?
Herbs.
I don't know. You'll have to
And,
ask Boda.
Oh, I think we're getting a little punchy here.
yeah, really,
we
must
are.
be good.
Very nice.
Must be after 10 o'clock, right?
Yeah, that's right.
Okay, so our next object is M62,
And guess what it is?
another globular star
globular
cluster in Ophiuchus. It's about 22,500 light
dropped
years
out again.
away. And I'm going to share my image while Richard tries to find the internet.
Now, Richard has
You're
to come
back.
back to the internet, so go have John show the image.
Okay, so
Okay,
here's the image of M62. Yet another globular star cluster. This one, again, is about 22,500 light years away in the constellation Ophiuchus. All right. And what did I say this was? M62,
62, right.
Okay,
M62. Yep.
so our next object is M6.
6.
Yeah, M6. I wonder,
Oh, yeah.
And after
Might
that,
this-
M7.
Very, very exciting.
Oh,
yeah,
yeah.
but-
This is,
the butterfly cluster.
A butterfly cluster.
Yeah. Well, I wonder if I have an image of that.
and if you
It's
can see
actually
it,
it's actually a controversial object because
I don't have an image of it.
All right, I'll show it real quick here. I got it.
if you see a butterfly in this, you're probably good at reading Horseshack diagrams too.
Yeah.
That's right.
Okay, so here's one set of wings right here. And here's another set of wings right here. I see a
Yeah.
butterfly.
Okay.
Yeah, right here and
Yeah.
right here, and I don't know what these are, but
Legs.
yeah, legs.
So this is about 1,600 light years away, and it's another open star cluster.
Well, that's the controversy. Is it really 1,600 light years away? Because there's all these estimates about distances.
Okay,
Anyway.
so that was M6. The next object is M7.
7.
Another
Open cluster.
open
yeah.
cluster. This one's
one's
about
neat.
800 light years away, and I don't think I know. I don't have an image of this one either.
Here, I'll
so-
grab this. Here we go.
And again, open star clusters are groups of stars that formed out of the same cloud of gas and dust and are drifting together through the galaxy, slowly spreading apart. All right, so this is Messier 7, M7. Now, the other one is another object that has a name that I could never figure out how it got the name. This is M11, also known as the wild duck.
Oh, yeah, the wild duck.
And I have no idea why. I do have an image of it though. Okay, maybe. Come
This
on.
is what happens when ducks get too wild.
Yeah. Now
Yes.
this is a Hubble image, and it's kind of zoomed in, but that's okay because even if you zoom out, I don't see anything that reminds me of wild ducks. So another open star cluster. This one is in the constellation Scutum. Scutum is near the constellation Aquila, the eagle, and this object is about 6,000 light years away, and was discovered actually almost 100 years before our friend Messier by a guy named Gottfried Kirsch.
Is that a double image of some kind or two pieces together? It looks like the A black
Yeah.
line
Oh
through the center
yeah,
of it.
black line right there. So it's a mosaic, huh? All right.
Well, that's a very zoomed in image, and you're certainly not
Yeah,
going to get a
yeah.
sense of a wild duck from that.
Now,
Well,
Yeah.
no matter what I've done, I even
Here, I'll show you this one. You can kind of get a sense of why they name it this way. So this is the zoomed out version, and here's the
really?
head of here's the head of the duck. Here's the head over here, and this is the body and the wings.
oh yeah, that's clearly a duck.
Yeah.
Oh
So
yeah.
here are the duck feet. The duck
You
feet.
say so.
I don't see it.
I haven't been drinking enough. So.
Maybe we need some cold duck or something.
Yeah, there you go. Okay, so our next object is M26, and I do not have an image of M26. It's another open star cluster, also in Scutum, about 5,000 light years away. Maybe you guys have an image.
Yeah, I do. If I can figure out how to share my screen. Here we go.
This one was discovered by our friend Messier.
This is in a really crowded part of the sky. It's
I'll say.
you almost can't believe that this is a separate object from the rest of the background stars, except you do notice that the patch of color here is different than the distribution around it. And so the fact that there's a concentrated number of these blue stars is the giveaway.
Okay, the next object is pretty spectacular. I'm going to show you a Hubble Space Telescope image that only shows part of this object. It's called M16. It is a star-forming region, a huge nebula that is condensing to form new stars. And
Don't search for it, Richard.
there's a very famous image taken by the Hubble Space Telescope called the Pillars of Creation. And so this is only a portion of M16, but what it shows is these what looks like pillars of gas and dust. And what you don't see is outside the frame of the image, up above, there is a couple of very young, very hot stars, excuse me, that are generating a tremendous amount of ultraviolet radiation. And radiation pressure is pushing the cloud that from which those stars formed. It's pushing the cloud away and creating pressure that's going in this direction. And as it does so, it wants to blow the cloud away, except that there's all these embedded young stars that have not yet fully formed within the cloud. And so as you look at this, if you look carefully, you see little nipples, if you will, on these fingers of gas. And those are where you have very young stars still embedded in the gas. Let me see if I can show a few of them. There's one. And I need to do a little cough here. Sorry, I can't get my mute button to come up. So anyway, this is all new stars forming within this cloud. One of the interesting things about this image, it's a false color image. And I really need to find my mute button here.
It's up by where it says stop sharing. Yeah. Gerald will be okay. He's fine.
Yeah.
Don't worry about him.
I've been doing too much talking here.
Yeah, it's all the talking.
So you see what looks like a kind of a turquoise background, and then kind of a yellowish, orangish color in the foreground. If this was a true color image, everything would be orange, just different shades of orange. This would be darker orange. The background would be lighter orange in color.
I have a wider image of it that looks like that if you'd like me to show it.
Okay, yeah, let's share that.
Okay.
While you're doing that, I'll do a little more coffee.
Yeah.
This one shows those stars that Gerald was talking about.
Oh yeah.
And it's
So
turned around a
point,
bit from the image that Gerald had, but you can still see it.
move your cursor over to those stars, John.
I think it's either these ones that he's talking about or these right in here. I'm not sure.
Okay.
I think it must be these out here. But you see all the orange color here.
Yeah, I think you're right.
But you know, the thing to really notice is you've got an orange background and an orange cloud. The orange cloud is darker, but it's everything is pretty much the same color, and that's because this is all a bunch of hydrogen, and it's being ionized and glowing. And in order to make that what they call the pillars of creation stand out, Hubble uses what's called the Hubble palette, and they deliberately take small differences in wavelength of the light, and they assign much bigger differences to those different wavelengths. So you end up with that kind of a turquoise color to the background and that dark orange color to the foreground, and that makes a lot more detail stand out. So that's M16, also known as the Eagle Nebula. Okay, our next object is M17. It is kind of a combination of a star-forming nebula along with an open star cluster. It's in the constellation Sagittarius, and I can share an image, I believe. Yes, I can. This is only a portion of that region. And so you've got all this nebula. Nebula is a word that means cloud. This is sometimes called the Omega Nebula or the Swan Nebula. It's also sometimes called the Horseshoe or the
every imaginable word. It's like
it's got a whole bunch of it's about 5,000 light years away, and you know, this image that you see here is taken by Hubble. It's kind of a close in image. Maybe one of you guys can find another image.
I've got one that kind of gives you a better sense of what it looks like through a telescope.
Right.
There you go.
Oh,
through a terrestrial telescope. Anyway.
And while you were doing that, John was kind enough to round up some cough drops for me. So
oh, good.
I'm going to mute.
Thank you, John.
Sure.
Good. All right.
So what do we have on this? Let's see.
Yeah, so I always think of it as the horseshoe because I see this dark thing around like this. The other descriptions I have a hard time with.
Yeah, that's still kind of close in to see that shape.
Okay, our next object is M18. We're just moving right along here.
Right through the numbers.
Yeah.
We're on object 91. We're getting close to the end, folks.
I wonder if we still have anybody with us. Let's check.
We do. We have like 75 people with us.
Oh, good.
So which one are we on? M18?
M18, yes.
Yeah. All right. It's another open cluster.
Do we actually still have people, or did we lose them?
Yeah.
No, we still got them. Yep.
No, we've got
a bunch in there.
We have like 40 people on Facebook and 50 people on YouTube right now.
That's interesting because I lost my Facebook thing, but now I've got it back.
Well, our internet has been a little unstable tonight, so
I also lost the YouTube. So,
well, they're still there.
Yeah,
okay.
I had mine to lock up a few times earlier too.
You may not be there, but they're still there. All right. So, do you want me to put up a picture of that, or do you have one?
I don't have one. So.
All right. Let me do that. And here we go. And you can see that this is not a particularly populated open cluster. I'm not going to say it's uninteresting, but
they're all interesting.
It's a little sparse. So we can move on.
Okay.
Okay. So
We
that was
are.
what, M18?
Yeah, so we're on 24 now, I think.
24. Yep.
Yeah.
M24. What can we say? Also called the Milky Way patch, and sometimes
Yeah.
called the Sagittarius star cloud. I'm not sure if I have an image
I've got a
of
nice
it.
image of this.
Yeah, I don't have one.
I,
So
I had forgotten that this was a Messier object completely, and
so this thing is about 10,000
yeah.
light years away. And it is a very odd looking thing. It's kind of like just a dark cloud out there. So it's probably a giant molecular cloud, which often appears as these dark patches out in space.
And that's what I was talking
confuse,
about earlier.
why
With
would he
Barnard.
confuse that with a comet? I don't know. But
Yeah. Well, when I was when
Well,
I was mentioning earlier that Barnard has a catalog of these dark clouds, and these would be, classic Barnard objects.
right.
Any of these dark clouds and patterns of dark molecular cloud.
Sure, Messier didn't have this nice Hubble image either.
No, he did not. I'm not sure what he was actually seeing.
All right.
Yep.
So our next object is M25, which I don't have an image of.
Another open
M25
cluster.
is an open cluster in Sagittarius, about 2,000 light years away. Hopefully we've got an image somewhere.
I got one here.
You might want to also bring up your star map and show where it is.
Yeah. On M25.
You also want to show where we are in the sky right now, because we're getting pretty far over. We're now down to about 4 o'clock in the morning.
It looks like we
doing this live.
must be in the Milky Way based on the background of this, but I'm not sure.
You said this is
in
M25.
Sagittarius.
Yeah.
M25
Yeah.
in
Okay.
Sagittarius.
Okay. Yeah. So.
All right. I'll stand by.
The heart of the galaxy here.
I want to pretend that we're at 5 in the morning, so stand by here. There we go. That brings it up. I'm just going to make it 6.
So we have several objects in the same region.
All right, here we go. I'm going to share my screen.
Is that it?
No, hold on. There we go.
Oh.
All right. So this is the part of the sky we're in, and we were looking at Scorpius. Let me collapse this image. We were looking at Scorpius earlier, remember, with Antares here, and which I still think means against Mars or rival to Mars, but we'll argue about this later. And
we'll take that offline.
And then there's M4, and down here is the teapot, or Sagittarius, and you can see why it's called the teapot. Here's the spout, and here's the lid, and here's the handle. And a lot of these Messier objects are collected right above the teapot. And the Milky Way actually is stretching right through this region here.
The center is just above where the spout is there.
Yeah, and you could think of it as the steam coming out of the teapot, right?
Right.
So M25, which is what we were just pointing out, is right here where the red circle is, and here were many of the other Messier objects that we were looking at previously.
And our next object is M23, which is in the same region, about 2,150 light years away, and yet another open star cluster.
This one is a little more interesting. I'll show a picture of that. It's got a little more substance to it. It's actually a pretty nice pattern. All right. And next is M21.
M21, yep.
Yeah. Yeah, another open cluster.
Yet another
Imagine
open
that.
cluster in the same region. This one's a little bit
Yes.
farther away, though. It's about 4,250 light years away, M21.
There you go.
All right. And
And M20
our
is next.
next one is M20, which is a little more interesting.
Yeah, absolutely. That's really interesting. This is
the
one of
tr-
my favorite objects.
Yep, this is.
Yes.
Do you have
Should
do you
we-
have an
do we-
image you want to show, or do you want to?
I have. Yes, I do.
Go for it.
Okay. All right. This is called, depending on who you talk to, the Trifid or the Trifid Nebula.
I'm a Trifid.
I like Trifid myself. It sounds like
I'll bet Gerald is Trifid.
Nope. I'm a Trifid guy too.
Okay.
So this is what we call a reflection nebula. It's actually light that's being reflected off this huge cloud of hydrogen. It's a large nebula. There is a new star sort of at the center of it, but most of the light we're seeing is not emission light, although some of it is, but it's also a reflection nebula. So it's a pretty spectacular object. You can also see these dark lanes. Those are high molecular weight clouds that have a lot more molecules rather than individual atoms in them. And again, it's a star forming region. All right.
Yeah, I've enjoyed photographing this one. I'll share mine real quick, just because I can. Yeah, and hold on for a second.
And this again is in
Sagittarius, right?
Yeah, so that was one I took here in California with an 11-inch scope. So there we go.
Let's see. Our next object is M8.
M8, another star forming region.
Yeah.
Also in Sagittarius.
Yep.
M8.
M8, the
Why is that not
lagoon.
ringing a bell? Oh, there we go. Lagoon. That's right. All right. You got a picture of that?
Yeah, I do. I do. I have a picture of a portion of it. This is only a small portion of it. Perhaps we have another picture somewhere that shows a larger field of view.
Oh, that's
I
really
have one.
close in.
This is a Hubble
John, you
Space
show yours
Telescope.
after Gerald's done. This is neat.
So is there any doubt that there's a cloud out there in space?
Yeah. That is definitely got the cloud.
Yep.
This is using the Hubble palette too, is it not?
Yes, it is.
Yes.
Yeah,
So
you
it
gotta
really
remember
brings
that-
out the detail.
Remember, these colors are generated by the use of what's called narrowband imaging, where they're
and
where they are.
embedded in this cloud are knots of gas that are condensing and forming new stars. So this is another star forming nebula.
Yep.
Okay, John, did you say you had another image
Yes,
of
I
this?
did.
This is 5,200 light years away.
So this is not
There we
zoomed
go.
in as much, but you can see.
But
a
it
lot of
gives
that
you a
area.
sense of why they call it the lagoon and
Right.
all that good stuff.
Okay.
Nice.
Right, our next object is M28. And let's see. Yes, I do have an image of it.
Okay.
M28 is a globular star cluster, also in Sagittarius, relatively close. It's 18,300 light years away. And I've got an image to share right there. Looks like a globular star cluster, right?
Yeah.
Indeed.
And this one was again discovered by our friend Messier.
Charles Messier. Yes.
Charles Messier. Charles. Okay.
You were going to say Pierre.
No. Okay. All right. So,
Charles Pierre. They're all friends.
And the next one is really nice, but it's another globular.
Next one is yet another globular star cluster.
It's big.
This one is
It's a big one.
Is M22. M22 is again in Sagittarius. It's about 10,400 light years away, and I do have an image, a Hubble image of it.
It's one of the first globular clusters to be discovered. This one in 1665 by Abraham Eiley, and Messier included it in his catalog 100 years later.
All right. And guess what? This is number 100 on our list. We have only
there.
10 more to go.
It's 100 on my list too, so our lists aren't that different.
Yeah. So let's see. Number 101 is M69. Okay.
Hey, another globular
cluster.
Imagine that.
Got a picture?
Hang on. M69.
Yep.
69. Yes, I do.
Now, this one's a little different than some of the other globular clusters we've looked at in terms of its stellar composition, because these stars are not as metal poor as other globular clusters.
So it might be a newer.
Yeah, globular. It's newer stars, more likely members of the galactic bulge population, because it's closer to the center of the Milky Way galaxy. So the bulge extended upwards and deposited some of those heavier elements.
Yeah, it's about almost 30,000 light years away. And again, it's in Sagittarius. And it's very close to yet another globular star cluster called M70.
70.
We had 69.
One number away.
Yeah. Well, they're right next to each other. He did try to go a little bit in order as he moved across the sky. So once again, another globular star cluster. Notice that this one is more compact at the center. That means it's a core collapse globular star cluster. And it's 29,300 light years away. And this one was discovered by Messier. And again, hundreds of thousands of stars, maybe close to 1 million stars, all packed very close together. Okay?
Yep.
All right. That was 101. 102 is that was 102. 103 is M54.
M54, right.
Another
globular cluster.
Imagine that.
This one's a lot farther away, though.
Yeah,
this is a very distant one.
87,400.
It's a pretty dramatic looking one too.
Yeah, yes, I do. This is definitely a core collapse globular star cluster. So you'll see that right away. See how dense it is at the core. Yes. All right. And that's this neat. One is pretty far away, 87,400 light years away. So it's way out there. It's in Sagittarius. When you're looking at Sagittarius, you're looking toward the center of our galaxy. But the center of our galaxy is only about 25,000 light years away. So what we're seeing is actually we're kind of looking through the central bulge on out to the other side of the galaxy where this globular star cluster lies. All right.
Amazing.
Okay, that is M54. Number 104 on our list is M55.
I'll bet you it's a globular cluster.
It just happens to be a globular star cluster. And this one I don't have an image of. So if you guys have one.
I do. Messier had a real hard time with this one because it would always be very low in the sky.
And he didn't discover it either.
Yeah.
Yeah,
so he would always try looking for it. I mean, I guess he found it a couple of times, but it would have been always very low in the sky in Paris, and because of its latitude, and He
It
struggled to find it.
It doesn't have as many stars as some of these other globular star clusters, maybe only 200,000 stars. Um, and it's only 17,300 light years away. So you got an image there? M55?
Yeah,
Yeah.
you should be seeing it.
Yep. Oh, okay. Yeah, I see it. Sorry.
All right, that's
All
all right.
right. Okay, our next object is M75, right? And guess what? It's another
Another globular
globular
cluster.
star
In
cluster
Sagittarius,
Yeah,
in Sagittarius.
there's lots of them there.
also pretty far away.
Yep. So let me share that. This is another one of those core collapse type
Yeah,
globular star clusters. Even
yeah,
farther,
that's
60,
that's really obvious.
67,000
Yeah,
67,500 light years away. And it's in Sagittarius. So we're looking beyond the central bulge out to the other side of the galaxy to see this.
And also, this one was discovered by Messier's pal Pierre Michon.
Yeah. We hope that's how we pronounce his name.
Yeah, something like that.
Okay, that's M75, which is number 105 on our list. M106 is another globular star cluster, but this is a very popular one. And it's in a different part of the sky. This is M15, a globular star cluster in Pegasus. And it is definitely a core collapse globular star cluster. In fact, it's kind of like the poster child for core collapse globular star clusters. We're pretty sure it has a intermediate mass black hole at its center. So let me share that image with you.
This is also another one that we view often from up here at
Yeah,
Chabot
yeah,
when we're
yeah.
open.
It's a
This is one of
relatively easy
one
one
of
to
my
find.
favorites.
It's
Yeah.
33,600 light years away. And when you're looking at this one, you're looking away from the central bulge of the galaxy. So this is M15, a core collapse globular star cluster in the constellation Pegasus. Depending on which depiction of Pegasus you're accustomed to looking at, it's off the nose of Pegasus. All right, near the star Enif. Okay, so that's M15. The next item is M2. And guess what M2 is?
Another globular cluster, this time in
Yeah.
Aquarius.
Yeah, this one is in Aquarius. It's about 37,500 light years away. I believe. Yes, I do.
Core collapse.
I don't know. It might be. Yeah, it looks like it might be. Yeah. So another one. I know it looks a lot like the one we just looked at.
Yeah.
So this is M2. Several 100,000 stars all packed close together, 37,500 light years away. And this is M2.
Unless you've viewed these things an awful lot, you would think a lot of these are just the same thing over and over again. They do look that similar.
Yeah, people are probably out there saying, no, these guys are just showing us the same object over and over again. Well, keep in mind there are 100.
Yeah, how would you know?
Right. There are 150, at least 150 globular star clusters orbiting around our galaxy. So, and they all look very similar. There are subtle differences, like whether or not it's core collapse and things like that. So don't be surprised that they look very similar to each other. Our next object is yet another globular star cluster in Aquarius called M72. And I've got an image of M72 here to share with you. It's a little less dense. This one is 55,400 light years away. And it's obviously not a core collapse because you can see gaps in the central part of it. So, all right.
Is this M72?
Yes.
M72.
I want
yeah.
to show you something interesting about this. Hold on for a moment.
Okay,
I'd like to
go
share an
ahead.
image.
Okay. This was
And,
also
this
discovered
is
by
actually
Pierre
kind of,
Michon
you know,
in
this is just a
1780.
neat image. This is from the Hubble Space Telescope. You guys see it?
Not yet.
I see a message that says Richard has started sharing his screen.
Yeah, we're okay.
We're in
Well,
the
the
home
next
stretch here.
yeah, the next object is M73. I don't have an image of it, and it's kind of a boring object. It's just a small group of stars. Um, Maybe we can find another image somewhere. It's 2,500 light
Let me
years away in the
see.
constellation Aquarius.
I
Yeah,
have
it's
a
an
not very
incredibly
interesting
dull.
image if you want it.
Okay, yeah,
They're all not interesting. Go
All
ahead and
right.
show it though.
yeah. There's not much to this object.
Yeah, there you go. That's a better image than the one I had.
Just a group of stars.
Hey guys,
Yeah.
I think I'm back on the internet connection. I really want to go back to that M73.
Sure,
Okay,
go on back.
okay. Have
All
at
right,
it.
I'm going to try sharing this just because this is kind of spectacular. Hold on for a moment. All right, tell me whether you see this image or not. Did you get it?
Looks like it. Yep.
Okay.
Yeah.
So
yeah.
look in the upper left corner here,
Yeah.
and I'm going to zoom in.
Oh yeah.
And look how you've got 1, 2, 3,
3,
4,
4.
5 galaxies at least. Right here in just the outer left corner of this globular cluster.
And
I think
none of
that's
them
neat.
are actually part of this
No,
Messier
no,
object.
no,
They
yeah.
just-
all distant background, very distant
Very,
background,
yeah.
probably in the neighborhood of 60 to 100 million light years away.
Okay, well,
Very
guys,
cool.
we are on number 110, Messier 30. Messier 30 is yet another globular star cluster. It's in the constellation Copernicus, and it would have been a hard one for us to.
I have
think it's-
never gotten this one in a Messier Marathon. I have.
Yeah,
The sun has always been too
right
high
before
up.
sunrise.
Yeah, right before sunrise.
I also think it's Capricornus, not Copernicus.
Oh, thank you, Capricornus. Copernicus, I know him.
Yeah.
So
He was a friend of Messier's, wasn't he?
Yeah.
It was.
Messier 30 is a globular star cluster 26,100 light years away in the constellation Capricornus. And it would be the last object we would try to image if we did a Messier marathon, and we probably wouldn't have been able to do it. It's low in the sky, and it pops up just like maybe an hour before sunrise, so it's
Nice.
already in twilight. So this would have been a tough one.
Nellie has a hard time getting that low in the sky.
Oh yeah, that's the
down
other
to
problem.
about 15 degrees above the horizon.
Right. So it would have been a tough one, but you got to see it tonight. So
All right.
all right, guys, we have done all 110 Messier objects.
Now we're going to do the whole thing again, right?
Yeah. That was the plan.
Yeah, we're not. But I
Took a little longer than we expected.
I got to say, 80 of you stuck it out with us tonight, and
We appreciate that.
we appreciate that. We're honored, and we hope you learned something. I certainly did. There's a lot of these Messier objects that I haven't looked at in close to 2 decades. And I always learn something new when I read about them and show them again. So this was really great. All right.
Well, I hope everybody enjoyed it.
Let's answer some questions.
Yeah, let's see what
are there
kind
any
of questions
questions
people.
from people?
Yeah,
see
the
what we
question
got
is,
here.
are you guys nuts?
Yes.
we
Yeah.
are completely nuts. There's absolutely no question about that.
Yeah, actually, the nutty part would be if we had actually stayed up all night to do this. You know?
Yeah,
Right.
yeah. That was the original plan. If there's
Yeah,
any doubt how
yeah,
nuts we
yeah.
are. All
All
right.
right.
Let's
Okay. Well,
see. Any
Germ says he
questions?
learned a lot tonight.
Good.
Uh,
Yeah, what was in the brownies? I'll tell you. Really, just a lot of chocolate and sugar. Yeah, that's enough. That's enough for me.
yeah, a lot of people apparently are happy that we're done here.
Yeah, yeah. Including
Yippee!
us. We're
Thanks for
happy
doing
that we're
this.
done.
And they're nice and warm inside, I'll bet.
Yeah. We're sitting
yeah.
out here in the cold observatory. So,
Here are the brownies.
yeah. Yeah, I see Jan Chwala is still here. Thank you, Chabot, for an interesting evening. Yes, we have cloudy skies. Yes, we are, in fact, completely overcast, windy, cold, wet outside. Definitely not the good night for doing a Messier marathon.
Oh,
No.
the Rosette Nebula is not a Messier object. So it has an NGC number, which I'll tell you I'll look it up for you. But yeah, it doesn't fall into the Messier list category. That was a question asked by Virginia. I'll give you that in a second. Rosette Nebula, which is really a fantastic nebula. It's NGC 2244. So if you search for that on Google, you'll find all kinds of wonderful images of that.
Yeah, they're actually, the Messier catalog is just a small collection of all the different faint fuzzy objects that are out there. There are a lot more. Most of them have NGC numbers. NGC stands for New General Catalog. It was a catalog that was started in the late 19th century.
Yeah. So not really new anymore, but
yeah,
it was new.
Yeah.
But there are many, many more objects in the NGC catalog than there are in the Messier catalog.
And we probably won't do a marathon session of all of those.
Yeah.
That ain't gonna happen.
Yeah.
There is something to. Alan pointed out that in case you have forgotten, you've got to move your clocks ahead an hour tonight.
Oh, very good.
Yeah,
point.
starting at 1:00.
That is at least the number one job of astronomers, is to remind you to set your clock.
Yes.
Even though we all hate the whole concept.
It is.
Yes,
it's the reason.
yes.
It's the reason the Chabot Observatory exists in the first place.
Yeah. We astronomers have a nasty name for daylight saving time. We call it darkness wasting time or darkness squandering time.
Yes.
Why anybody would want to switch to daylight saving time and lose an hour of sleep and be all groggy come Monday morning, I don't know. And then there's this proposal to go permanently on daylight saving time, which is nuts. But and not just because of the astronomers. There's other reasons. They tried that once before, and it was a bad idea. So why they want to do it again, I don't know. So anyway, change your clock tonight.
Well, it's the definition of insanity,
Yeah. Keep doing the same thing over.
Keep doing the same thing over and over again.
Okay.
All right.
Well, if you have any more questions, shoot them now or forever hold your peace.
Or at least for a week.
Yeah. We will be back again doing this next week. We'll do it at our normal time, 9:00 at night, and we'll just do a normal virtual telescope program, assuming the weather cooperates with us. And you can join us.
And if not, we'll do another weird one.
Yeah.
Photos.
I don't know. Do we ever do anything that's normal?
And once again, we want to remind everybody, Chabot Space and Science Center is closed right now because of the pandemic, but we are continuing to do things, especially all this virtual programming that we're doing, and there's a lot more virtual programming coming up. And we do have staff who work on all of this, and they need your support. Since we don't have people coming into the facility, We rely a lot on your donations. So if you're on Facebook, you'll see a donation button at the top of the page. Otherwise, you can go to Chabot's website, chabotspace.org, and you'll find a donation button up at the top of the web page there. Check it out. Make a donation. We really appreciate your support.
And stay tuned. Go ahead, Richard.
Oh, I'm sorry. Aside from all of the resources on the web, if you Google Messier or Messier Marathon, this is a really good book by Don Mackholtz, the Messier Marathon Observer's Guide. It's not a really highly polished book or anything, but it is chock full of information. And it gives you the order in which to do a Messier Marathon and has star maps and lots of other interesting information in it. So, Jill, I hope that helps.
Yep. Just remember, you have to do it in mid March, because that's the only time when all of these objects are viewable through the course of one night. All right.
And I was just going to say, stay tuned to Chabot. We've got some very big announcements coming up soon.
Yeah.
So keep listening in on us.
Yeah, we got all kinds of good news for you.
All right. Well, any other questions?
I think that's it. All right. Well, good night, everyone.
Okay.
Good night. Stay warm.
Thank you for joining us, and we will see you next week.
All right. Take care, all. See you next week.